Hello there, and welcome to the Snoozy Scientist, where we explore life's deepest mysteries, one sleepy yawn at a time. I'm so glad you've chosen to spend a little part of your evening, your morning, or some quiet in between moment here, winding down with me. Tonight, we'll be drifting through some of the strangest things NASA has quietly discovered in space. You see, NASA points its eyes at the stars every single day. And space, well, it's supposed to be predictable, cold, vast, quiet, but every so often it isn't, because sometimes something unexpected shows up. NASA's satellites have captured moments that never made the news, because not everything they find can be explained, and not every discovery comes with a theory. NASA's archives are full of wonders, but tucked between the headlines and the mission logs are a few entries no one likes to talk about. And tonight, we're opening those. From the Bermuda Triangle of space, where satellites glitch and spin wildly out of control, to eerie screaming sounds that don't sound like space, but rather like a voice screaming from a distance. Some described it as ghostly, others simply called it the scream. These aren't conspiracy theories, they're real observations, real anomalies, logged and archived by NASA, tucked between thousands of lines of data, waiting for someone to notice. And tonight, that someone is you. Before we drift too far into space, I'd love to know, where in the world are you listening from right now, and what time is it there? It always brings me joy to see how far these gentle science stories float across time zones and continents. And if this story helps you unwind, if it sparks your curiosity, or helps you slow your thoughts just enough to fall asleep, I'd be truly grateful if you'd tap like or subscribe to the channel. Your support helps keep this small channel going. Now get cozy. Maybe pull the blanket a little tighter, dim the lights, and let your imagination settle softly. Because tonight, we're going to explore NASA's most disturbing space discoveries. And once we begin, there's no unseeing what's out there. The Unnamed Red Object. It started, like many things in astronomy, with a flicker. Not a flash, not the brilliant burst of a supernova, or the rhythmic pulse of a known radio star, but something softer, stranger. It appeared in a deep sky survey conducted by one of NASA's infrared telescopes, a faint red glow far beyond the belt of familiar stars. Just one dot, tucked into a cluster of otherwise empty sky. It wasn't cataloged, it didn't match any existing coordinates. It was, in every sense, new. And at first, that was all it was, a red shimmer in the dark. But the longer NASA watched it, the stranger it became. Because this object wasn't just glowing, it was glowing in rhythm. Every 6.5 seconds, the red light would pulse, not flicker, not flare, but pulse, soft, symmetrical, unwavering, like a heartbeat. And each pulse was paired with a low-frequency radio emission, like a signal trying to travel across an unimaginable distance. Faint, but measurable, a repeating pattern that didn't match anything from known stars, galaxies, or spacecraft. It wasn't a star. Stars don't pulse that way, not in red, not in intervals that precise. It wasn't a planet, either. Planets don't emit radio signals in timed bursts. And it certainly wasn't a satellite or space debris. It was far too distant and far too regular. The team that first documented it nicknamed it the Red Whisper. It didn't have a formal name because officially it wasn't classified as anything at all, just an unidentified transient object, a placeholder title used when something appears in one set of observations, but doesn't yet belong in any known category. The pulses were what kept the team watching. Hour after hour, night after night, the red glow continued, 6.5 seconds on, 6.5 seconds off, never changing, never fading, as if it were waiting for someone to notice, as if it were intentional. Some thought it could be a pulsar, the leftover core of a massive star spinning rapidly, shooting beams of light like a cosmic lighthouse. But the light was too soft, the spectrum was off, and most puzzling of all, the pulses didn't decay. Over time, pulsars slow down. This one didn't, not even a little. Others wondered if it could be a quasar, a brilliant galaxy core feeding on gas, flaring with electromagnetic noise. But quasars are violent, chaotic. This object was the opposite. It was gentle, measured, patient. There was also the unsettling detail that the pulses seemed to be structured. When analysts mapped the radio bursts, they noticed small variations, tiny differences in pitch and spacing, so subtle they were almost imperceptible. But when plotted across time, the changes formed patterns, not noise, not randomness, something else. One researcher described it as too clean to be natural, but too subtle to be artificial. It was the kind of statement that didn't make it into the final report. But it lingered, whispered among those who had seen the raw data. There was something about it, something not quite right, not wrong, exactly, just other. Eventually the signal faded, not all at once, but gradually. The pulses began to soften, the timing stretched. Then, one night, it stopped. No flare, no final burst, just silence. Follow-up observations turned up nothing. The red glow had vanished, no trace, no explanation, and so it was filed away, tucked into a digital drawer labeled unresolved. The red whisper was never mentioned in a press release. It never made the rounds on science blogs, but it stayed quietly in the archive, logged by time, date, and frequency. What was it? A failed star? A rogue object wrapped in an electromagnetic shell? Or something we don't yet have words for? Something watching or listening or reaching out in the only language it knows? NASA never gave it a name, perhaps because giving it a name would mean admitting it existed, and not everything the agency observes is ready for explanation. Still, the data remains: the 6.5-second heartbeat, the structured whispers, the quiet glow that hung for a time in the middle of nothing. And while that signal faded, others have not. Elsewhere in the sky, new anomalies began to emerge in regions once thought empty, now pulsing with unexplained signals of their own. One of the most curious among them was discovered while studying a different phenomenon entirely, a place where space itself behaves like a glitch in reality. The cold spot anomaly. It was a map unlike any other, not of stars or planets or galaxies, but of temperature. In 2003, NASA's Wilkinson Microwave Anisotropy Probe, better known as WMAP, finished scanning the sky for something ancient, something left over from the very beginning of time. It was looking for the faint echoes of the Big Bang, a kind of cosmic afterglow called the cosmic microwave background. This faint radiation is everywhere. It fills space like a whisper left behind by creation itself, a snapshot of what the universe looked like when it was just 380,000 years old. It's not light you can see, but it's always there. And when mapped properly, it reveals patterns, tiny differences in temperature that shape the structure of the universe. Warmer spots show where matter clumped together. Cooler spots show where it thinned out. It's like looking at the fingerprint of the cosmos. For the most part, the map looked as expected. Tiny blotches, smooth gradients, familiar distributions. But in one region, it didn't. There, in the constellation Eridanus, WMAP found something that made scientists pause. A large patch of sky that was colder, significantly colder than everything around it. Not by a few fractions of a degree, but by a wide, measurable margin. It stretched across 1.8 billion light-years of space, and the temperature drop was more than statistical noise. It was real, and it was big, too big. They called it the cold spot. Now, in a universe that runs on mathematics, size and shape matter. Anomalies can happen, random patches, slight variations, but this one was different. According to the standard model of cosmology, the cold spot simply shouldn't exist. The odds of such a large cold region forming by chance were incredibly small. Some estimates suggested less than 1 in 10,000. Scientists tried to explain it. Some wondered if it could be a shadow, not a literal one, but a phenomenon caused by something between us and the radiation, a region of empty space that distorted the light passing through it. That theory led to an even stranger idea, a supervoid. A void in space is just what it sounds like, an area with fewer galaxies than usual. Space, while vast and mostly empty, still has structure. Galaxies clump into clusters, which stretch into filaments, which twist into massive webs. Between these filaments are gaps, voids. But this one? This one was massive. If the cold spot were caused by a supervoid, it would have to be the largest ever discovered, 1 billion light years across, an absence of galaxies on a scale that defies the laws of structure formation. It would be quite literally the emptiest part of the known universe. Even so, some researchers accepted the idea. They tried to map the void with galaxy surveys. They looked for missing matter, dips in gravitational lensing, faint shifts in the redshift of light. And for a while, they found hints, sparse regions, missing clusters. But nothing that could account for the full coldness, nothing big enough, nothing that made it make sense. Others went further. They proposed that the cold spot might not be part of our universe at all. Some cosmologists suggested the possibility of a cosmic bruise, a mark left by a collision with another universe. According to certain models of inflation theory, our universe might be one bubble in a vast multiverse, and sometimes those bubbles could bump into one another, leaving behind faint scars. The cold spot, some theorized, might be just that, a collision zone where the edge of our universe brushed up against another. It sounds like science fiction, but the math isn't entirely outlandish. The shape, the size, the symmetry, they don't rule it out. They don't prove it either. But they leave the door open, and sometimes, in science, that's all it takes for an idea to stay on the table. Even today, the cold spot remains one of the strangest features in cosmology. It has no definitive explanation, no standard model to fit neatly into, just a vast, quiet patch of sky that's colder than it should be, sitting quietly in the background of everything we know. It's still there, every time we look, still cold, still empty, still unaccounted for. And while some scientists continue trying to explain it away, others have turned their attention elsewhere, to nearer mysteries, closer to home, like a strange object hovering silently in Earth's orbit, one that's been there for longer than any of our satellites. The Black Knight Satellite. Not every mystery is buried deep in space. Some have been orbiting right above us, hiding in plain sight. Long before the cold spot sparked whispers about other universes, a different kind of enigma had already captured the imagination of scientists and sky watchers alike, one that didn't hover in distant galaxies or radiate strange pulses from billions of light years away, but one that lingered quietly in near-Earth orbit. It's often called the Black Knight Satellite. That name didn't come from NASA or any official space agency. It came later from amateur researchers, radio operators, and satellite trackers who noticed something odd, something orbiting Earth, that no one could identify. It all began with radio signals. Back in the late 1890s, long before rockets, long before spaceflight, Nikola Tesla claimed to have received an unusual transmission while experimenting with early radio equipment. He was convinced the signal wasn't from Earth. Years later, in the 1920s and 30s, amateur radio operators began reporting what they called long delayed echoes, signals that bounced back after strange, inexplicable delays, as if something far above Earth was catching them and sending them back. At the time, no one had the language for satellites. The very idea of objects circling Earth was still confined to science fiction. But as decades passed and space programs emerged, the picture began to change. In 1954, several years before Sputnik became the first official satellite, newspapers reported that the U.S. Air Force had detected two unidentified objects in orbit. The reports were brief, unexplained, and quietly brushed aside. But they stirred something, especially when, in 1960, the U.S. Navy spotted a dark tumbling object in polar orbit. At the time, neither the United States nor the Soviet Union had the technology to place satellites in polar paths, the kind that cross over both the North and South poles. It required more energy, more precision, and yet there it was, a black object moving silently in a trajectory we weren't capable of executing yet. NASA dismissed it as space debris. Some said it was a piece of a lost spy satellite. Others suggested it could have been a casing or an old fragment of earlier missions. But none of those explanations fit well, because when later missions photographed the object, it didn't look like scrap. One of the clearest images came from NASA's STS-88 mission in 1998. As astronauts worked on assembling the International Space Station, a series of photographs were taken showing a dark, angular object floating just beyond the reach of the craft. It wasn't shaped like a satellite. It wasn't smooth or symmetrical or man-made in the way we usually recognize. It looked jagged, uneven, almost organic in its geometry, like something that was meant to be in the shadows. NASA stated that the object was likely a thermal blanket, a piece of insulation that had broken off during a previous EVA. But that explanation didn't sit right with everyone. The blanket theory accounted for part of the sighting, but not the entire timeline. It couldn't explain the early radio echoes. It couldn't explain the orbital path tracked decades before the ISS even existed. And it didn't match earlier photographs taken long before that mission. To this day, the Black Knight remains one of the most debated artifacts in modern space lore, not because of what it is, but because of how long it might have been there. Some researchers believe it could be thousands of years old, that it may be a probe, not of ours, but someone else's, a sentinel, quietly watching, listening, waiting. The idea sounds fantastical, but even mainstream scientists admit we've only mapped a fraction of what's floating above our planet. There are thousands of known satellites, tens of thousands of fragments, but not all of them behave like we expect. Not all of them fit our logs, and when something doesn't have a launch date, or a serial number, or an origin story, it stays in the margins. Even now, satellite trackers occasionally report unidentified objects in low Earth orbit, dark masses that don't match anything listed. They don't transmit, they don't shine, but they're there. Maybe the Black Knight is just a shadow, a trick of light, a misidentified fragment lost in the noise of our growing orbital cloud. Or maybe it's something older, something that was here long before we looked up, and might still be here long after we stop. Just above us it turns, quietly, patiently, always in orbit. And while it watches, something else has been speaking. A strange sound, captured not far from one of the largest planets in our solar system. A sound that no one expected to hear. A scream, where there should have only been static. The Saturn hexagon, far beyond Earth, past the scarred red plains of Mars and the drifting moons of Jupiter, Saturn turns slowly in the cold. With its iconic golden rings and thick atmosphere, it's a planet we've gazed at for centuries, beautiful, distant, and almost unreal. But hidden at its north pole is something that still leaves scientists blinking at their screens. A storm, but not just any storm. This one is shaped like a perfect hexagon. It was first captured clearly in 1981 when NASA's Voyager 1 probe flew past the gas giant. As it passed over the northern hemisphere, the probe sent back images that showed something impossible, a six-sided jet stream, spinning steadily around the pole, so geometrically precise it looked artificial. Each side of the hexagon stretched nearly 9,000 miles, longer than the diameter of Earth, and yet the lines between them were sharply defined, like something traced with a ruler. At first, the shape was dismissed as an image artifact or a trick of light, but then Voyager 2 flew past and saw the same thing. Years later, the Cassini spacecraft arrived and spent over a decade orbiting Saturn. It confirmed what Voyager had only hinted at. The hexagon wasn't a glitch, it was real, and it wasn't going away. Unlike storms on Earth, which spin and break apart with time, Saturn's hexagon remained stable. For decades, it rotated like clockwork, a swirling cloud shaped structure with sharp angular edges and a strangely calm eye at the center. Scientists tried to explain it. In wind tunnel experiments and fluid simulations, they managed to reproduce similar shapes under just the right conditions. By spinning liquids at certain speeds inside circular tanks, six-sided patterns began to form. It was a promising lead, but these models only worked on small scales, and Saturn's storm was anything but small. No one could say why Saturn, a planet made mostly of hydrogen and helium, would have the perfect balance of pressure, wind speed, and rotation to keep a storm shaped like a polygon spinning for decades. Nor could they explain why the hexagon formed only at the North Pole, not the South. Even stranger, the deeper Cassini looked, the weirder it got. Inside the hexagon, lightning flickered through the clouds, lighting up layers of atmosphere hundreds of miles deep. Some of the flashes were 10,000 times stronger than lightning on Earth, crackling with an energy that hinted at turbulence far beneath the surface. And as the seasons on Saturn changed, something unexpected happened. The color of the hexagon began to shift. At first, it was a pale blue, ghostly and translucent, but over time it turned gold, then a dusty amber, as though the storm were aging or reacting to sunlight in ways we don't yet understand. Some images taken by Cassini even showed shadows along the edges of the hexagon, cast by towering clouds, suggesting that parts of the storm were rising upward like massive walls, not just flat, not just spinning, but rising vertically with depth and structure. For a while, some scientists quietly wondered if the shape could be caused by something deeper, maybe even something solid beneath the clouds. But Saturn doesn't have a rocky surface like Earth. Its layers dissolve into gas and pressure the farther down you go. There's no floor, no stable ground for anything to rest on, so the shape must come from movement, from physics, from the balance of wind and gravity in a world far colder, darker, and stranger than ours. Still, the symmetry lingers. Six sides, equal lengths, sharp corners, all moving in perfect unison. Even on a planet known for its beauty, the hexagon doesn't feel natural. It feels placed, like something built into the planet's atmosphere. A signature, a boundary, or perhaps a beacon, endlessly turning without a sender or a receiver. It's been watched for over 40 years, and still no one knows what drives it. No one knows what's at its center. But while Saturn's hexagon turns on in silence, somewhere else in our solar system, silence was broken, not by light or shape, but by sound. Farther out, another NASA probe was passing through the intense magnetic field of a neighboring giant. It expected static, charged particles, noise, but what it picked up instead was something that sounded very much like a scream. The screaming sound from space, while Saturn's perfect hexagon spun like a silent engine in the clouds. The Juno spacecraft was making its way toward a very different kind of storm, one not shaped by wind or geometry, but by magnetic fury. Jupiter is the largest planet in our solar system. It's massive enough to hold more than 1,000 Earths inside its volume, and powerful enough to bend light, distort gravity, and trap radiation in fields so intense they would fry ordinary electronics in seconds. It's not just a planet, it's a swirling, roaring force of nature. And when NASA launched the Juno mission in 2011, it did so with caution, because getting too close to Jupiter meant stepping into the largest magnetic field of any planet we know. This magnetic field, called a magnetosphere, stretches millions of miles into space. It's shaped like an enormous teardrop, pulled and compressed by the solar wind. Inside it, high energy particles race at tremendous speeds, creating a zone of radiation so extreme that Juno had to be specially armored just to survive its orbits. As Juno approached Jupiter's poles, the regions where the magnetic field loops inward, it passed through bands of charged particles and plasma waves. These weren't things you could see, but they could be recorded as electromagnetic signals. And that's when it happened. As Juno crossed into Jupiter's auroral zone, it picked up a noise unlike anything heard before. The signal wasn't random. It wasn't a hum or a static buzz. It was a rising, warbling wail, like a slow buildup of tension in the air, swelling into a high-pitched shriek and then dipping into strange echoes that seemed to fall away into space. It was eerie, mechanical, alive. When converted into sound waves, the recording became even more unsettling. It didn't sound like space. It sounded like something screaming. NASA called the signal plasma wave emissions, naturally occurring phenomena created by the movement of charged particles along Jupiter's magnetic field lines, but hearing it felt different. The sound had rhythm, tone. It rose and fell like a voice stretched thin by distance. Some described it as ghostly, others simply called it the scream. And in a way, the description wasn't wrong. What Juno had captured was a kind of space weather, a chorus of electrons being accelerated through invisible pathways, colliding with gases, and releasing bursts of energy that shimmered through the planet's upper atmosphere. These interactions created massive auroras, glowing lights at the poles, like Earth's northern lights, but far more intense. The auroras on Jupiter span thousands of kilometers, flickering with ultraviolet colors no human eyes can see. But while Earth's auroras glow quietly, Jupiter's come with noise, with distortion, with bursts of electromagnetic pressure that ripple through space like echoes in a canyon. Juno passed through it all, again and again, as it orbited closer and deeper into Jupiter's magnetosphere. The spacecraft kept listening. It recorded dozens of these bursts, each one slightly different, each one sounding just a little too deliberate. The sounds weren't signals in the traditional sense. They weren't messages, but they weren't random either. They followed the patterns of the planet's invisible structure, like a weather map made from sound. Some of them lasted only a few seconds, others went on for nearly a minute, building layer upon layer of harmonic distortion. It wasn't the only time NASA had heard strange things near Jupiter. Earlier missions had also picked up bursts of decametric radiation, lower frequency waves that created deep, crackling rumbles when translated into audio, but nothing was as sharp, as high-pitched, or as haunting as what Juno recorded. These sounds don't just exist near Jupiter, they're part of a larger system, one that links Jupiter's massive magnetic field to its many moons. One of those moons, Io, is the most volcanically active body in the solar system. Its eruptions spew material into space, feeding the magnetosphere with sulfur and plasma, which in turn creates more of these electromagnetic shrieks. It's like a chain reaction, a symphony of invisible violence that never ends. And through all of it, Juno drifted, protected by thick shielding, equipped with instruments designed to listen, to measure, and to survive. The recordings were shared publicly, played at conferences, uploaded online. People listened. Some laughed nervously, some turned the volume down, because whether or not you believe space can scream, it's hard to unhear what Juno brought home. But just as Jupiter howled, another world not far away seemed to whisper, a place far quieter and far smaller, a place we thought we knew until we found tunnels just beneath its surface. Tunnels large enough to hide cities or something else entirely. The moon's deep caverns, while Jupiter screamed through its magnetic field and Juno floated quietly through the noise, another world was revealing its secrets in near silence. Much closer to home, our own moon, long thought to be still and silent, began to show signs that it wasn't quite as simple as we once believed. We've been looking at the moon for thousands of years. Its soft glow has marked time, shaped calendars, inspired poetry, and in 1969, when humans first set foot on its dusty surface, we believed we were stepping onto a dry, lifeless rock, ancient, cratered, and still. But decades after those early missions, new instruments began scanning the moon in far more detail. NASA's Lunar Reconnaissance Orbiter, launched in 2009, carried with it powerful radar systems capable of peering below the surface. It was meant to map, to measure, to understand the moon's structure. What it found was an opening, then another, and then more. Near the moon's equator, in a region known as Marius Hills, researchers discovered something unexpected: deep pits, perfectly round, with sharply defined edges. They looked like sinkholes, wide mouths in the surface, each one dozens of meters across. At first, scientists thought they were just collapsed craters, but as the data came in, it became clear these pits weren't empty. They were entrances, windows into something much larger below. What lay underneath were lava tubes, ancient tunnels carved not by water, but by flowing magma, billions of years ago, when the moon was still volcanically active. These tubes had once carried rivers of molten rock beneath the crust, and when the lava drained out, they left behind massive hollow corridors. Unlike on Earth, where gravity and erosion eventually collapse these kinds of structures, the moon's lower gravity and lack of atmosphere allowed them to remain intact, untouched for eons, sealed in vacuum and silence. Some of the caverns are believed to be hundreds of feet wide and stretch for miles, tall enough to hold skyscrapers, long enough to contain entire cities. And the deeper NASA looked, the more potential they saw. Inside these lava tubes, the temperature remains stable, around minus 63 degrees Fahrenheit, far less extreme than the surface, which swings wildly between searing heat and freezing cold. Radiation levels are lower inside. Micrometeorite impacts, which constantly bombard the moon's exterior, wouldn't reach within. That realization sparked a question that still lingers today. If we were to build a base on the moon, why build on the surface at all when there are ready-made chambers waiting just below? NASA and other space agencies have already begun studying how these tubes could be used to shelter future lunar missions. Designs have been sketched, robotics programs proposed. One idea involves sending drones to lower sensors into the pits, mapping them in 3D. Another proposes inflatable habitats, carried inside and expanded like balloons to fill the caverns with breathable space. But for all the planning, there's something quietly unsettling about the idea, because these tunnels have been there for billions of years, untouched, hidden, and no one truly knows what's inside. Some of the openings are so deep that even the most advanced imaging tools can't see to the bottom. They fall into darkness quickly, with steep walls and smooth floors. Shadows pool at their edges like still water, and inside there is only silence. We've never sent anyone into one. No rover has rolled across their floors. No camera has scanned their ceilings. All we have are radar echoes, thermal readings, and digital reconstructions, outlines of a vast and hollow underworld carved into the bones of the moon. And while most researchers are focused on exploration and colonization, a smaller group has asked different questions. What if these spaces weren't always empty? What if at some point they were used not by us, but by something else? The moon has long been the subject of speculation, from strange lights on its surface to brief flashes captured by telescopes that have never been explained. Now, with evidence of vast inner chambers, the quiet questions have grown louder. Could anything have survived down there, or hidden? We don't know. Because for now, those tunnels remain sealed, dark, untouched. But we do know they exist, and that's enough to wonder what else lies beneath the places we thought we knew. And as we turn our eyes back to the surface, not of the moon, but of a red planet farther away, another image begins to form, a face carved into dust, watching from the shadows of another world, waiting to be explained. The face on Mars, from the moon's dark tunnels to the cold, rust colored plains of Mars, the surface of another world began revealing shapes that stirred something deep in our imagination. It was 1976. NASA's Viking 1 spacecraft was orbiting Mars, sending back images of its dusty, windswept terrain. The photographs weren't high resolution by modern standards. They were grainy, black and white mosaics stitched together line by line. But they were good enough to map the land and scout possible landing zones for future missions. Then, over a region called Cydonia, one photo came back different. It showed a mesa, a raised area of rock, like a natural platform, stretching about 2 miles long and 1 mile wide. At first glance, it looked like any other Martian hill, but as the light hit it just right, shadows pooled across its surface, and in those shadows, a shape emerged, a face, broad, symmetrical, with what appeared to be eye sockets, a ridge for a nose, and the suggestion of a mouth. It stared upward from the Martian soil with quiet stillness, not carved or drawn, but formed by the play of light and structure. NASA noted the oddity, but brushed it off as a trick of perspective, an example of pareidolia, the human tendency to see faces in clouds, wood grain, or rock formations. It was filed, cataloged, and left at that, but the public noticed. When the image was released, it quickly spread beyond science circles. Newspapers published it. TV shows discussed it. Was it artificial? A monument? A relic of something long gone? The question swirled, not just in conspiracy forums, but in living rooms and classrooms. For many, the face felt too precise to be natural. People pointed out the symmetry, how the eyes seemed evenly spaced, how the mouth appeared aligned beneath a central nose. Others claimed to see more, nearby structures that looked like pyramids, geometric alignments that echoed patterns on Earth. Some even suggested that the face was positioned to line up with solstices or planetary orbits. NASA remained quiet for years, but in 1998, they finally returned with better tools. The Mars Global Surveyor orbited Mars with a far more advanced camera. When it passed over Cydonia, it took new images of the same mesa, clearer, crisper, more detailed. This time, the shape looked different. Gone were the deep shadows and strong contrasts. What was left was a rugged hill, uneven and wind-worn, with natural ridges and valleys. The face was gone, or so it seemed. NASA released the image with a short explanation. The original face had simply been a trick of lighting and low resolution. The new photo showed what had always been there, a rock formation, nothing more. But for some, the explanation didn't sit right. They argued that even with better resolution, the structure still held a certain symmetry. The slope of the ridges, the placement of the features. It wasn't as dramatic without the shadows, but the underlying shape remained. And more importantly, they asked, why only one new image? The Cydonia region is vast, yet few high resolution photos were released from that area. Some independent analysts claimed that multiple passes were made over the region, and not all images were shared publicly. Whether that's true or not, it added fuel to an already burning question. Was the face ever truly debunked, or was it simply dismissed? In 2001, NASA's Mars Odyssey mission added more scans to the conversation, and again, the images pointed toward a natural formation, but the story didn't go away, because the face on Mars was never just about the photograph, it was about the possibility it suggested, not of ancient aliens or grand civilizations, but of something older than that. The idea that Mars, long before it turned red and silent, might have had something worth remembering, that maybe it wasn't always dead, that perhaps in some lost era, something stood there long enough to leave behind a trace. Even now, scientists acknowledge that Mars once had rivers, lakes, maybe even oceans. It had an atmosphere, it had time, and where there is time and energy, there's always the possibility of form, shaped either by nature or something more. Whether the face was ever real doesn't seem to matter anymore, because it did what all the best mysteries do. It made us look closer, it made us wonder, and in that wondering, new questions began to surface, especially when NASA's probes, drifting ever farther into space, began to pick up interruptions, glitches, bursts of unexpected data from instruments that were built to endure the vacuum. One such probe, heading toward the edge of the solar system, suddenly began to behave differently, as if something out there in the deep had reached back or reached in. Voyager's sudden silence. The year was 1977. Two spacecraft, identical in design but bound for different directions, left Earth carrying golden records and hopeful messages from humanity. They were small, silent machines named Voyager 1 and Voyager 2, tasked with exploring the outer planets, Jupiter, Saturn, Uranus, Neptune, and then continuing outward into the deep. They were only meant to last a few years, but decades passed and the Voyagers kept going. Their cameras were shut off long ago to conserve power, but their antennas still pointed home, and their instruments still whispered data back across the void. Day after day, year after year, they traveled farther than anything we've ever built. Eventually, the stars behind them shifted. The pull of the sun grew weaker, and then they crossed a boundary no spacecraft had ever reached, a place where the solar wind fades, where the magnetic bubble surrounding our solar system ends. Interstellar space. It isn't empty, it's filled with thin plasma, drifting magnetic fields, and radiation from distant stars. It's dark and quiet, but not silent. And when Voyager 1 crossed into it in 2012, something strange began to happen. NASA's Deep Space Network, a global array of giant antennas, had been listening to Voyager's signals for over 35 years. Normally, those signals arrived as steady streams of data, tiny fluctuations in voltage, translating into measurements of temperature, magnetic fields, and particle density. But now, there were interruptions. The first signs were brief data spikes, flashes of information that didn't make sense, too sharp, too sudden. Instruments that had been calm for months would show bursts of static, then silence. At first, it was chalked up to distance. Voyager 1 was over 11 billion miles away. The signal was weaker than a whisper, a billionth of a watt. A passing solar flare or a wobble in Earth's rotation could easily bend the connection. But the pattern continued. Not random, not constant, just odd. Voyager 1 would send normal data for weeks, and then suddenly, one instrument would spike. The plasma sensor might report an impossible reading, a sudden jump in density or energy, as if the spacecraft had passed through a wave. Then the magnetometer would go quiet, or the orientation system would briefly stop responding. Most alarming was when the attitude control system, responsible for keeping the antenna aimed at Earth, seemed to drift, very slightly, just enough to weaken the signal. It corrected itself quickly, but not without leaving a gap. For hours at a time, the spacecraft would vanish from NASA's screens. Then, as if nothing had happened, it would reappear. The team on the ground reviewed every subsystem. Power levels were stable, heat levels were within range, no impact events, no known radiation bursts, just gaps, just whispers, just silence. And then, in 2020, another anomaly. Voyager 2, which had entered interstellar space a few years later, experienced a full data blackout for several days. Every system went dark, telemetry vanished, NASA prepared for the worst. But then, just as engineers began troubleshooting backup procedures, the signal returned, clear, undamaged. Voyager 2 picked up exactly where it had left off. No memory of the silence, no signs of stress. The spacecraft was unaware anything had happened, but something had. Scientists began to wonder if both Voyagers had passed through regions of interstellar turbulence, places where magnetic fields and ancient shock waves collided, creating invisible disruptions in space itself, like weather, like storms. If so, the instruments aboard Voyager weren't just observing deep space, they were moving through something not solid, not visible, but there. Others proposed more exotic ideas, that the signals weren't breaking up due to interference, but because of interference with time, that the spacecraft moving at the edge of the sun's influence might be experiencing space differently. That data wasn't being lost, but delayed, bent, reshaped. There's no proof of this, of course, only gaps, only strange returns. And through it all, the golden records still spin. Each Voyager carries music, greetings, and etched instructions, a message to anyone or anything that might find them drifting through the dark. They are time capsules of our world, cast into the stars, and yet, even as they leave us behind, something still reaches back. Every now and then, one of them flickers, pauses, stops responding, as if listening to something we can't hear. And as Voyager slips farther into the unknown, a new light begins to dim. A star, once steady in its brightness, starts to flicker in irregular patterns, as though something large and not entirely natural is passing in front of it. Something that blocks the light, but not randomly. Something that might have been built. The alien megastructure star. As Voyager continued its long journey through the silence, NASA's eyes turned toward a distant patch of sky where something far stranger was unfolding. Not a whisper this time, not a spike of static or a burst of interference, but a flicker, a change in brightness, so subtle, yet so unsettling, it caused astronomers to pause, look again, and then ask questions they weren't quite prepared to answer. It began in the constellation Cygnus, where a star named KSE 8462852 quietly shimmered among thousands of others. It wasn't especially large or young or dramatic. It looked like many other stars, steady, consistent, glowing with soft white light. But as data from the Kepler Space Telescope poured in, this one star began to stand out. Kepler had one job, to find planets by detecting tiny dips in a star's light, the gentle shadows that pass across a star's surface when a planet moves in front of it. These dips are usually smooth, predictable, and rhythmic, but what Kepler saw at KSE 8462852 was nothing like that. Instead of small, regular dips, the star's brightness dropped sharply, then recovered, then dipped again, deeper this time, and not at regular intervals. Some dips lasted a few hours, others went on for days. The brightness would plummet by as much as 22%, then rise again as if nothing had happened. No pattern, no symmetry, just chaos. This wasn't what a planet looked like. A planet might block 1% of a star's light, 2% maybe for a gas giant. But 22? That would take something massive, something irregular, something large enough to block a fifth of a star's light, and strange enough to do it without a rhythm. The star, which soon earned the nickname Tabby's star, after lead researcher Tabitha Boyajian, became an instant mystery. Scientists ruled out known causes. Not a planet, not a comet swarm, not dust clouds or eclipsing stars. None of it made sense. The behavior didn't match anything in the models. It was quite literally an unexplained dimming of a distant sun. And that's when a different kind of theory emerged. It wasn't the first idea offered. It wasn't even taken seriously at first. But it came from a place of scientific honesty, the willingness to consider the unthinkable when the ordinary doesn't fit. A few researchers very carefully suggested that the dimming might be caused by an alien megastructure, specifically something known as a Dyson swarm, a theoretical collection of solar collecting satellites that could surround a star to harvest its energy. Not a solid shell, but a cloud of machines, orbiting in overlapping paths, absorbing light and beaming it somewhere else. If such a structure existed, it would cast uneven shadows as it moved. Irregular dips, no repeating pattern, just like Tabby's star. The idea caught fire in the public imagination. Headlines screamed about possible aliens. Interviews with astronomers became filled with careful phrasing, emphasizing that artificial structures were a last resort, not a conclusion. Still, the thought hung there, quiet and thrilling. NASA and SETI, also known as Search for Extraterrestrial Intelligence, turned their antennas toward the star, listening for signals. No radio waves came back, no pulses, no messages, just silence. Whatever was dimming the star wasn't communicating, at least not in any way we could detect. Over time, new theories emerged. Maybe the star had swallowed a planet and the debris was still circling. Maybe a giant dust cloud, shaped by magnetic forces, was passing through. Maybe it was something even simpler, something we didn't yet understand about stars themselves. But none of these answers fully explained the erratic patterns. The star continued to flicker. It dimmed again in 2017, and again in 2019. Each time, telescopes watched closely. Each time, the dips were different. The mystery hasn't been solved, and maybe that's part of its weight, the way it lingers just outside the reach of certainty. A quiet, flickering light, thousands of light years away, doing things no other star seems to do. And while most scientists now lean toward natural explanations, the original question remains suspended in space. What if it isn't natural? Because the universe doesn't owe us clarity. It simply offers patterns, some we can read, and some that remain just out of focus. And as that star dims and brightens in the distance, another object much closer to us entered our solar system with no warning. It moved quickly, it spun strangely, and just like Tabby's star, it left behind more questions than answers. The interstellar visitor, Oumuamua. While Tabby's star flickered in the distance, hinting at something vast and unexplained, a much smaller mystery slipped quietly into our solar system. It didn't announce itself with light or signal or flare. It came in fast, moving faster than any object we'd ever tracked before, and by the time we noticed it, it was already on its way back out. It was first spotted on October 19th, 2017, by astronomers at the University of Hawaii using the Pan-STARRS 1 telescope. At first, it looked like a faint streak of light, just another small asteroid or comet drifting among the stars. But when they plotted its path, everything changed. This object wasn't orbiting the sun like the planets or comets usually do. It was passing through on a hyperbolic trajectory, meaning it had come from outside the solar system and it would never return. It was the first object of its kind ever observed, an interstellar visitor. They named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. It was fitting. This thing had traveled for millions, maybe billions of years through deep space before slipping past the sun and being noticed by us, just briefly before vanishing into the void. Right away, astronomers tried to learn everything they could, but the object was moving fast, over 87,000 miles per hour, and getting dimmer by the day. Telescopes across the world scrambled to observe it before it disappeared completely. They measured its brightness, its rotation, its speed, and almost everything they found only deepened the mystery. For one thing, Oumuamua didn't look like anything we'd seen before. Most asteroids are roughly spherical or potato-shaped, lumpy and irregular. But this object was long and narrow, like a cigar or a flattened shard. Estimates suggested it was up to 800 meters long, but only about 80 meters wide, a shape more than 10 times longer than it was wide. It tumbled end over end every few hours, reflecting sunlight in strange ways. As it rotated, its brightness changed drastically, suggesting it had an oddly shiny reflective surface. Some scientists speculated it might be covered in metallic or glassy material, like polished stone or frozen carbon, but the real surprise came when they tracked its path through space. As Oumuamua moved away from the sun, it should have slowed down, just like a rock tossed into the air eventually falls back. But it didn't. Instead, it accelerated slightly. It wasn't much, just a small but measurable push, as if something invisible were giving it a gentle nudge. This was common with comets, which often outgas as sunlight warms their icy surfaces, creating a faint thrust. But Oumuamua didn't show the usual signs of a comet. No tail, no visible gas or dust, just silence and speed. So what was pushing it? Some researchers tried to explain the acceleration as a result of hydrogen outgassing, invisible jets of hydrogen escaping from the surface as it warmed, but no one could prove it. Others proposed more exotic ideas, that it might be a thin sheet, like a solar sail, pushed by sunlight itself, something built, not formed, something artificial. The idea wasn't presented as fact, it wasn't shouted from rooftops, but in published studies and quiet interviews, respected scientists, including Harvard's Avi Loeb, began to suggest that we shouldn't dismiss the possibility. After all, if you were to send a probe between stars, you wouldn't make it bulky. You'd want something light, flat, reflective, efficient, the kind of thing that could pass by quietly, measure, observe, and move on. But Oumuamua didn't pause. It didn't scan or orbit or hover. It simply moved in, then out. No signal, no course correction, no evidence of design beyond what nature might also produce. Still, the shape, the spin, the acceleration, the silence, and then it was gone. Within weeks, it faded beyond the reach of our best instruments. We couldn't chase it. We couldn't bring it back. All we had were the measurements, the images, the questions. In the years since, no other interstellar objects have matched it exactly. A second one, 2I Borisov, entered the solar system in 2019, but it behaved more like a typical comet, with a visible tail and no strange acceleration. Oumuamua remains an exception, the first visitor, the unknown messenger. And as it fades into the black beyond Pluto, attention has returned to the sky, to the stars that sometimes vanish without warning, not dimming like Tabby's star, not fading like Umuwama, but disappearing completely as if erased from the sky, with no explosion and no trace. The disappearing stars, as Oumuamua slipped quietly into the dark, leaving behind nothing but questions and faint light curves. Attention turned to something even harder to explain, something that didn't flicker like Tabby's star or pass through like a visitor, but something that simply vanished. Stars, by their nature, don't just disappear, they burn for millions or billions of years, slowly exhausting their fuel. When they die, they do it loudly. A massive star might collapse in on itself, creating a brilliant supernova, an explosion so bright it can outshine an entire galaxy for days or weeks. A smaller star might fade gently into a white dwarf, cooling over time into a quiet ember. But in 2019, astronomers analyzing years of data from telescopes, including the Kepler Space Telescope and ground based surveys, noticed something different. In a small region of the sky, a star that had once been catalogued was no longer visible. Not dimmed, not pulsing, not changing, gone. It wasn't the kind of mystery that grabs headlines at first. Stars are small points of light scattered across immense distances. Telescopes blink. Data is messy. Mistakes happen. But this wasn't a one time glitch. It was part of a pattern. A team of researchers working through a project called VASCO, Vanishing and Appearing Sources during a century of observations, began comparing modern sky maps to images taken nearly 100 years ago. They wanted to find objects that had changed significantly over time. What they found were stars that no longer existed in the present day sky, not because they had gone supernova, not because they had exploded or shifted, but because they simply weren't there anymore. In total, over 100 objects were flagged. Not all were confirmed stars. Some could have been data artifacts, but a handful stood out, objects that had appeared consistently in older sky surveys, across multiple images, sometimes over decades, and then vanished. One particularly strange case involved a star that had been visible in the 1950s and 1960s, bright and steady, but in modern surveys, using far more powerful instruments, the same region showed nothing at all. Not a faint glow, not a remnant, just darkness. This wasn't supposed to happen. Stars don't vanish without leaving evidence. Even if a star collapsed directly into a black hole, skipping the supernova stage, it would still affect the surrounding space. Its gravitational pull would remain. Its light might flicker or stretch. But here, there was nothing. No sign of motion, no afterglow. It was like erasing a pixel from the universe, clean, quiet, and complete. Some theories began to circulate. Could these be stars that collapsed into failed supernovae? Stars so massive they folded into black holes instantly without light? That idea gained traction. Some models suggested it was possible, but rare. And again, that kind of collapse should still affect its surroundings. Yet the regions around the vanished stars looked unchanged. Others considered more exotic explanations. Could these be transient objects, phenomena that mimic stars for a time, only to vanish when they've served their purpose? Could they be stars partially hidden behind clouds of cosmic dust, shifting slowly over time? Or perhaps light echoes from distant one-time events? There was also the quiet whisper of something more speculative. If a civilization had the ability to construct massive structures, something on the scale of Dyson swarms or stellar engines, could it cloak or dismantle a star entirely? Could a star be harvested, dismantled, or obscured on purpose? No one claimed it outright. No one said it was aliens. But when stars vanish without trace, the conversation opens wide. The Vasco project continues. Thousands of stars are still being reviewed. New survey images are constantly compared to those from older archives, looking for more signs of disappearance, more quiet exits, and all the while, telescopes scan the skies for updates. Most stars remain where they've always been, but sometimes, rarely, a speck of light that's been there for generations simply isn't. No bang, no flare, just the absence of what once was. And while these missing stars raise questions about what can vanish, another mystery was stirring on a far more familiar world, one where strange patterns were forming in the sand, shifting quietly as the seasons passed. A world with no wind to explain the movement, but plenty of watchers wondering what might be crawling just beneath the surface. Dark dune spots on Mars. As stars blinked out of existence without warning, questions turned toward those that remained, and toward planets orbiting beneath them. If a star could vanish without a trace, what smaller mysteries might be hiding in their shadows, especially on a world we've studied more than most? Mars has always felt like a mirror held up to Earth, cold, red, and quiet, but familiar enough to haunt us with possibility. For decades, we've sent rovers and orbiters there, scanning its dusty plains, peering into its canyons, tracing the ghost of water that once ran across its surface. And in all that watching, there was something strange, something that kept showing up in one particular place. In the high latitude regions of Mars, particularly near the southern polar dunes, NASA's orbiters began picking up something unusual. As Martian spring approached and the surface ice began to melt, dark circular spots started appearing across the frozen dunes, like shadows, but not cast by anything visible. They weren't there in winter, but come spring, the surface would bloom with them. They were named dark dune spots. To a casual observer, they looked like smudges, charcoal colored patches spread across smooth, pale sand. But they didn't just appear, they moved, not like boulders or avalanches, more like a slow, quiet spread, forming, fading, then returning in slightly different shapes and places the following year. These weren't just surface stains. Some of the spots showed distinct radial patterns, as if something beneath the surface had burst outward. Others had fuzzy edges, almost like mold expanding in all directions. Their placement was oddly consistent, always on dunes, always in spring, always dark against the light. Scientists first assumed they were a seasonal quirk. Perhaps carbon dioxide trapped beneath the ice was warming and exploding upward, leaving behind a disturbed surface. Mars, after all, has strange seasons. In winter, dry ice, frozen CO2 settles over the poles. When sunlight returns, it warms the ice from below, sometimes creating geysers of gas that break through in small bursts. These bursts, they thought, might explain the spots, but some researchers weren't convinced that all the features could be explained by frozen gas alone. A few of the spots appeared to have central cores that changed brightness over time. Others left marks that returned in nearly identical patterns the following Martian year. One set of observations even suggested that the darkest parts of these spots absorbed more heat and held onto it longer than the surrounding terrain. Then came the strangest part. Inside the dark cores of some dune spots, instruments detected traces of hydration, tiny hints of water or moisture, inconsistent with the dry surrounding sand. And some spots exhibited behavior that scientists quietly described as lifelike, not alive, but oddly similar to how certain colonies of Earth microbes behave when exposed to cycles of sunlight, temperature change, and ice. That word, lifelike, echoed louder than expected, because if anywhere on Mars could harbor seasonal, protected, hidden microbial life, it might be here, in sheltered dunes beneath layers of ice that preserve moisture and shield against radiation, with seasonal sunlight to trigger activity. Mars is not a place where life thrives, But if life survived, buried deep and ancient, this would be a place to look. NASA has never confirmed anything biological. These spots remain labeled seasonal surface features. Most explanations still lean toward CO2 outbursts, erosion, or chemical reactions, but no one has fully mapped or explained all of them, and no lander or rover has ever gotten close enough to sample them directly. For now, they remain marks from afar, shifting signals across a distant desert. Each Martian year they return. Each year they're slightly different. Some shrink, some multiply, some fade away completely, but they always come back, and in the silence of Martian spring, as the dunes warm and the light stretches long across the frost, the surface of the planet seems to stir, not with wind or movement, but with change, a quiet transformation that repeats year after year like a breath no one hears. As the dark dunes breathe in the spring thaw, another kind of spiral was being studied far away, not in the sand, but in the stars, a whirl of glowing arms twisting across space, pulled by forces that shouldn't be there, galaxies spinning, not as expected, but with a hidden hand guiding their motion. The phantom galaxy rotation. While Mars offered strange signs that something might still be stirring beneath the dust, far beyond our solar system, scientists were confronted by something even more puzzling, not on a planet, but in the very structure of entire galaxies. When you look at a spiral galaxy, it resembles a cosmic pinwheel, elegant arms stretching out from a bright, dense center. These arms are made of stars, gas, and dust, all orbiting a shared gravitational heart. It looks peaceful from a distance, but when NASA and other astronomers started measuring how fast these stars were actually spinning around their galactic centers, something was off, very off. In our solar system, the further a planet is from the sun, the slower it moves. Mercury zips around quickly, while distant Neptune takes over 160 years to complete just one orbit. This makes sense. Gravity weakens with distance. It's the basic rhythm of celestial motion. But galaxies don't seem to follow that rule. When scientists measured the rotation speeds of stars in spiral galaxies, they expected the outermost stars, the ones farthest from the center, to move more slowly. Instead, they found that these stars were moving just as fast as those near the core. Some were even moving faster than they should be, based on the amount of mass visible in the galaxy. It was as if something invisible was gripping these galaxies by the edges and spinning them like a wheel, something that shouldn't be there, yet had undeniable weight. To explain it, astronomers proposed the existence of dark matter, a mysterious substance that doesn't emit light, doesn't reflect it, and can't be seen directly. But it must be there, they said, because the math demands it. Without this extra hidden mass, the galaxies should tear themselves apart. They're spinning too fast for their own good. These strange rotation curves, flat rather than falling off with distance, were found not in just one galaxy, but in nearly every spiral galaxy studied. It became a pattern so consistent that ignoring it was impossible. Still, the thing doing the holding, this unseen mass, remained just a theory, a placeholder, a shadow we can't touch. To get a clearer picture, scientists turned to radio telescopes, infrared scans, and gravitational lensing, watching how light from distant galaxies bends around massive objects. The way the light bends reveals where the gravity is strongest, even if the mass itself is invisible. Time and time again, the light bent not around visible stars or gas, but around vast regions of empty-looking space. It was as if something vast, a ghost-like scaffold, was woven into the universe, holding galaxies together, shaping how they spin, guiding the movement of stars, and yet never making itself known. And the strangest part? No one knows what dark matter actually is. It's not made of atoms. It doesn't interact with light. It's not dust or black holes or any known form of regular matter. It only shows itself through its gravity, a kind of silent influence, like something hiding in plain sight, shaping everything but staying forever out of reach. Some scientists began to wonder, what if dark matter isn't a thing at all, but rather a flaw in how we understand gravity? What if, on galactic scales, gravity behaves differently than it does here on Earth? Alternative theories were proposed: modified gravity, quantum fields, but none could fully match the observations across all galaxies. And so, the invisible hand remains. There are even entire galaxies that appear to have no dark matter at all, rotating in strange, unpredictable ways that defy every model. Others seem to be entirely made of dark matter, with barely any stars. It's as if the universe is built on a framework we're only just beginning to detect, a scaffolding of shadow. To map this unseen structure, NASA launched probes and satellites like the Wilkinson Microwave Anisotropy Probe and the more recent Euclid mission. They aim to trace the fingerprints of this hidden mass, its distribution, its density, and how it clumps around galaxies. What they found painted a startling picture. Dark matter isn't spread evenly, it clumps into webs, great cosmic filaments stretching across billions of light years, with galaxies hanging like beads on threads of gravity. We live inside one of these filaments, unknowingly held in place by strands of something we can't see, and still, we don't know what it is. It might be a type of particle never detected in any collider, or it might be something even stranger, a property of space itself. But whatever it is, it's holding the stars in their dance, keeping the galaxy from unraveling, wrapping entire clusters in its silent grip. And as telescopes reach deeper, they've begun to notice subtle shifts in other things: strange X-ray pulses, flickers of unseen motion, and soft trails of energy coming from places that should be empty. Signs that something powerful and invisible is still active. Because in the deep background of space, there are other lights, too bright, too focused, and far more intense than stars, and they're pouring out X rays at levels no one expected. The ultraluminous X ray mystery. There's a kind of light we can't see with our eyes. Not red or blue, not even ultraviolet. It's higher than that, beyond the energy of visible light. It's called X-ray radiation, and space is full of it. NASA's space telescopes, like Chandra, were built to detect this invisible form of light. What they found wasn't just the faint background glow of the universe, but something much brighter. In fact, they found objects that shine in X-rays so intensely they earned their own name: ultraluminous X-ray sources, or ULX. At first, scientists thought these powerful emissions were just black holes consuming nearby material. That's a common X-ray generator in space. Matter falls toward a black hole, heats up and releases radiation before disappearing. But there was a problem. The intensity of these ULXs didn't fit the black hole model. They were too bright, sometimes hundreds of times brighter than the theoretical limit a black hole of that size should emit. It's called the Eddington limit, the maximum brightness an object like a star or black hole can emit before the pressure of the light it produces pushes away any additional incoming matter. Think of it like a cosmic traffic rule. A black hole can only eat so fast before the light it produces blows everything else away. But these ULXs, they broke the speed limit. That left astronomers confused. Either something was wrong with our understanding of physics, or these objects weren't black holes at all. So they looked deeper. Some ULXs pulsed like a heartbeat. That ruled out black holes entirely. Why? Because only neutron stars, the crushed dense cores of once massive stars, could pulse like that. But again, neutron stars also have a limit to how bright they can get, and these were well beyond that too. A star the size of a small city, spinning dozens of times per second, releasing X rays at blinding intensity, and yet somehow not tearing itself apart. To make matters even stranger, these ultra-luminous X-ray sources weren't just rare anomalies. NASA found them in dozens of galaxies, scattered like breadcrumbs across the cosmos. Many were located just off-center in galaxies, not in their bright cores where supermassive black holes usually sit. They seemed misplaced, like something roaming, and they didn't all behave the same. Some flickered, others stayed constant. Some exploded in short bursts and then vanished for years. There was no pattern, just energy pouring out from places no one expected, following no clear rule. One ULX in particular, cataloged as M82X2, caught NASA's attention. When it was first discovered, it appeared to be emitting more than 10 times the energy allowed by the Eddington limit. Yet there it was, stable and repeating, pulsing with perfect regularity. Not chaotic, not collapsing, just steady. This was one of the moments when scientists started to quietly say the words "we don't know." And in the background, a few quieter voices asked, what if these aren't natural? If not black holes and not neutron stars, could they be something else? The idea of an advanced civilization harnessing X rays sounds like science fiction. But in theory, civilizations capable of engineering structures around stars, so called Type 2 or Type 3 civilizations on the Kardashev scale, might produce enormous amounts of energy using unknown technologies. And if those technologies emitted radiation, X rays would be a prime candidate, focused, powerful, and nearly invisible. That wasn't the official explanation. NASA stuck with the neutron star theory, modified by a handful of new equations that try to explain how such small objects can emit such massive light. The models are complex and controversial. Some believe strong magnetic fields might channel material directly onto the surface, concentrating energy in narrow beams that appear ultra bright when aimed at us. But this explanation only fits some of the ULXs, not all. Others suspect we're seeing intermediate mass black holes, the mysterious in-between cousins of stellar black holes, and the supermassive ones at the centers of galaxies. But those have never been directly confirmed either. They're a hypothesis built on shadows. So what are we left with? Dozens of sources, massive energy, no consistent theory, objects that shouldn't exist, yet continue to shine across space, quietly and without explanation. And perhaps most unsettling of all, some of these sources seem to move slightly over time, not anchored, not static, floating, as if they're not bound to where they began, as if they're not part of the galaxy's structure at all, as if they were placed. And while astronomers keep refining their models and updating their maps, the light continues to shine, brighter than it should, quieter than expected, and far more mysterious than anything we were ready to find. And just when we think we're catching up, something even stranger appears next. The lost tape from Apollo 11. We've all seen the footage, the grainy black and white image of a man climbing slowly down a ladder, the voice crackling through the radio. That's one small step for man, and the ghostly view of footprints pressed into powdery lunar dust. The Apollo 11 moon landing is one of the most iconic moments ever broadcast, a shared moment in human history, watched by an estimated 600 million people around the world. But what if that footage wasn't the original? Because according to NASA, it isn't. In the early 2000s, a quiet announcement was made that left some historians, scientists, and space enthusiasts stunned. NASA had lost the original moon landing tapes, not misplaced, not buried in a forgotten vault, but erased. The tapes that recorded the very first steps taken by humans on the surface of another world had been recorded over. The official explanation? NASA was facing a shortage of magnetic data tapes in the 1980s. High quality reels were expensive and constantly in demand, so, in a cost saving effort, hundreds of tapes from earlier missions, including Apollo, were reused. Among them were the original slow scan TV recordings of Apollo 11. Now, this raises a strange technical point. The footage the world saw in 1969 wasn't exactly what NASA recorded. The video captured on the lunar module used a format called slow scan television, SSTV, which wasn't compatible with standard broadcast signals on Earth. So NASA converted it in real time. A camera was pointed at a special monitor that displayed the SSTV feed, and that image was broadcast to the world. The result? A slightly degraded, lower quality image, what we all know as the moon landing video. But the original tapes, those would have shown a clearer, sharper, more detailed version, better contrast, better resolution, and potentially more detail from the lunar environment than we've ever seen. Those tapes would have shown exactly what the astronauts saw, without a camera filming a screen. But they're gone, gone from NASA's archives, gone from history. When the story first came to light, it sparked quiet confusion, then louder questions. Why weren't those tapes immediately backed up? Why didn't anyone recognize their value? Why was there no high security process for preserving them? NASA responded with an internal investigation. They admitted the tapes were likely part of a batch that had been degaussed, wiped clean, and reused to store satellite data in the 1980s. They weren't stolen, they weren't hidden, just erased, because at the time, the agency didn't fully realize what they had lost. But some weren't satisfied with that answer, because if you think about it, NASA keeps meticulous records, flight logs, telemetry samples, even trash from missions is archived. How does the most important video in human spaceflight history not receive the same treatment? What's more curious is that it took decades for anyone to even notice the tapes were gone. By the time anyone asked for the originals, they had already been destroyed. It's not that NASA tried to hide this, they were honest eventually. But the idea that no one thought to preserve the clearest version of mankind's first steps on the moon, it doesn't sit easily. It leaves behind a vacuum, not in space, but in the story. And when a vacuum forms, speculation fills it. Some wonder what else was on those tapes. Did the original footage capture things the public version didn't? Strange shadows, odd reflections, glimpses of something in the distance. Was there anything off about what the astronauts saw? There's no official evidence for any of that, but it doesn't stop people from asking, because when information disappears, especially something so historic, it creates a kind of quiet unease. It's not always about conspiracy. Sometimes it's about memory, about the idea that we once had something and now it's gone. NASA eventually restored the public version of the broadcast using cleaner broadcast copies and modern digital tools. They even released a remastered version of the televised moonwalk. It's better than before, but it's still not the original. What's missing isn't just pixels. It's a direct window to one of humanity's greatest moments, unfiltered, undistorted, unreconstructed, and that window was wiped clean. Some of the Apollo telemetry data still exists, some voice recordings too. Even handwritten notes from the mission controllers are archived in fireproof rooms. But the most powerful image of all, the live view of man's first contact with another world, was lost because of a tape shortage. Now we're left with fragments, recovered bits from television networks, backup reels, audio-only transmissions. But the master tape, the one that captured the moment the lunar module's shadow crossed the Sea of Tranquility for the very first time, no longer exists. And while we still celebrate that moonwalk, part of it now feels more distant, less vivid, like a dream we know we had, but can't quite replay. And just as we try to hold on to what's already vanished, the next discovery waiting in NASA's files doesn't offer comfort. It only deepens the mystery. The deep space silence. You would think that in all the years we've been listening, we would have heard something by now. For decades, enormous radio dishes have pointed into the sky, listening, waiting, hoping that across the emptiness, some distant intelligence might whisper back. The search for extraterrestrial intelligence. SETI isn't science fiction. It's a scientific initiative that NASA and other organizations have quietly supported, aiming antennas at the stars and scanning the skies for anything unusual, a pattern, a pulse, a signal not made by nature, and yet the silence is absolute. From the late 1970s onward, powerful radio telescopes like the one at Arecibo scanned slices of the universe, tuning into cosmic frequencies the way you might scroll through a quiet radio dial at night. But nothing speaks. There's static, noise, bursts from quasars and pulsars, but no message, no signal that says we're here. And that silence, it's more than just quiet. It's unsettling, because space is big, incomprehensibly big. The number of potentially habitable planets we've discovered in just our corner of the galaxy is already in the thousands, and estimates suggest there could be billions more across the Milky Way. So, how is it possible that in all that vastness, there's not even a hint of another voice? Scientists call it the Fermi paradox. If intelligent life is common, why haven't we heard from it? There have been blips, moments that almost seemed like contact. In 1977, a powerful narrowband signal was picked up by the Big Ear radio telescope in Ohio. It lasted just 72 seconds. The astronomer on duty circled the printout and wrote "Wow" in red ink, and ever since, it's been known as the "Wow" signal. But that signal never repeated. It came once, then never again. Some believe it was a natural phenomenon. Others still wonder. Since then, listening has only intensified. More sensitive equipment, more refined algorithms, dishes covering wider sky regions. But year after year, the results remain the same: silence. One possible explanation is that space is simply too vast. Signals fade over distance. Even a powerful transmission sent from a planet 1,000 light years away would weaken until it blended into background noise. Maybe we're listening, but we're too far, too late. Another possibility, we're listening for the wrong kind of signal. Most of our SETI searches are tuned to narrowband radio waves, what we'd expect ourselves to send. But what if intelligent life evolved differently? What if they don't use radio at all? Or worse, what if they did, but stopped long ago? Technology evolves. On Earth, we're already transitioning to fiber optics, laser communications, and quantum encryption, things that don't leak into space. Maybe advanced civilizations go dark. Maybe radio signals are just a brief blink in their history. Maybe we're searching for a whisper in a language no one uses anymore. And then there's a darker thought. What if someone or something doesn't want us to hear anything? Some researchers have considered the idea of a cosmic filter, a limit, a point in a civilization's development where progress becomes dangerous. Maybe societies reach a stage of intelligence, start broadcasting, and then disappear. Perhaps broadcasting your presence into the void is not a survival trait. If that's true, maybe the silence isn't emptiness. Maybe it's caution. Maybe everyone out there is listening, but no one dares to speak first. There are also theories that advanced beings could intentionally hide their signals using cloaking technologies or nonlinear methods of communication beyond our understanding. That space isn't silent, it's encrypted. Even stranger, some have suggested we're already surrounded by messages, encoded in starlight, buried in gravitational waves, or pulsing faintly from distant quasars. But we don't yet know how to listen correctly. Imagine watching a movie but without understanding the language, the culture, the symbolism. You'd see the images, but the meaning would be lost. Maybe we're watching the cosmos the same way, seeing everything, understanding nothing. In all this quiet, NASA and its partners haven't given up. The Allen Telescope Array, Breakthrough Listen, and other efforts continue to comb the skies. New AI systems now help parse the endless static, looking for patterns a human might miss. There's still hope that a signal will come through, and still, the silence stretches on. It's a silence so deep that it feels heavy. It raises more questions than answers. Are we early? Are we late? Or are we alone? And yet, perhaps, silence isn't a sign of nothing. Perhaps it's the sound of something immense holding its breath. Because the longer we listen, the more the silence feels intentional, like space itself is waiting for us to ask the right question. And the next entry in NASA's files might bring us closer to hearing a response. Planet 9, or something worse. Far beyond the familiar orbits of Neptune and Pluto, there's something off. Astronomers noticed it not through direct sight, but through motion. Tiny icy objects in the Kuiper Belt, a frozen region beyond Neptune filled with scattered debris, weren't orbiting the way they should. Their paths were being tugged, subtly but consistently, by something invisible, something massive. That's when the whispers of Planet 9 began. It wasn't just one anomaly. Several distant objects showed signs of being shepherded into strange elliptical orbits, all pointing in the same direction, as if being pulled along by a giant hidden magnet. But no planet was there. Telescopes found nothing. And yet the gravitational fingerprints suggested otherwise. This theoretical Planet 9, if it exists, would be about 10 times the mass of Earth, orbiting so far away that a single year could last between 10,000 to 20,000 Earth years. It wouldn't reflect much light. It would drift slowly, cold and faint in the far reaches of our solar system, far beyond Pluto's lonely path, too dim to detect easily, yet heavy enough to move entire belts of debris. The idea of Planet 9 isn't new. For over a century, astronomers have speculated that another large body might lurk beyond the known planets, disturbing their orbits from afar. But what's changed is the math. The patterns are too precise to be random. Something is definitely there, or something is happening that mimics the presence of a massive planet. Some researchers have even suggested that it may not be a planet at all. Instead, it could be a primordial black hole, a theoretical remnant from the early universe, smaller than a tennis ball, but heavier than Earth. If such a black hole were caught in orbit around our Sun, it would be impossible to see with traditional telescopes. It would not emit light, nor reflect it, but its gravitational influence would ripple through the solar system, just like Planet 9 seems to be doing. That thought alone is enough to unsettle even seasoned scientists. A black hole quietly drifting through our solar system? Invisible, ancient, and endlessly patient? There are other theories too. Some suggest that perhaps we've misunderstood gravity at these extreme distances, that something in the fabric of space itself is skewing our models, or that the outer edges of our solar system are being tugged by something outside of it entirely, a passing star, a hidden swarm of dark matter, or even the faint gravitational pull of another star system slowly brushing up against ours. Still, the most commonly held belief remains that there's a massive planet out there, one we just haven't found yet, and finding it could rewrite what we think we know about the formation of our solar system. If Planet 9 exists, it could explain the strange tilt of the Sun's axis. It might even help solve why so many distant objects have clustered together like marbles circling a drain. Some researchers speculate that this mystery planet may have once been a rogue, a wandering world from another system, captured by our sun's gravity billions of years ago. But others caution, what if it's not just one object? What if the outer solar system is filled with hidden masses, objects that have never been seen, but whose quiet weight tugs on everything around them, shifting the balance of our cosmic backyard without ever showing themselves? NASA's Wide Field Infrared Survey Explorer WISE telescope has tried to detect the heat signature of large objects beyond Pluto, but so far nothing definitive. The search continues, now with ground based telescopes like the Subaru telescope in Hawaii, which scans the darkness for the faintest motion, a slow blink in the sky that might reveal a distant frozen giant. Until we find it or prove it doesn't exist, the question lingers like a cold wind through space. What exactly is out there, shaping the edges of our solar system? Whatever it is, it's been patient, and as we slowly improve our tools, scanning pixel by pixel through the black, we may finally see the shadow of what's been hiding all along, or discover that what we've been sensing isn't a planet, but something far stranger. And the strange doesn't end here, because further out, beyond this icy mystery, is a region where signals vanish, satellites fail, and navigation becomes impossible, a place astronauts call the Bermuda Triangle of space. Dark matter's uncomfortable implications. For centuries, space was thought to be mostly empty, a black void between stars, punctuated by the occasional comet or wandering planet. But as our instruments became sharper and our understanding deeper, we realized something disturbing. There's more out there than we can see. Or rather, there's something we can't see, but we have to believe is there. Otherwise, the math simply doesn't work. That something is dark matter. Imagine watching galaxies spin according to the rules of gravity. The stars on the outer edges should move more slowly than those near the center, just like planets orbiting our sun. But they don't. They race around at incredible speeds as if something invisible is holding them together. This invisible glue is what scientists call dark matter, and it doesn't glow, reflect, absorb, or interact with light in any way we can detect. It passes through normal matter like a ghost. It can't be seen directly, but its gravity, that's undeniable. Without it, galaxies should tear themselves apart. Clusters of stars should drift away. The universe as we know it shouldn't even hold together. NASA has mapped the gravitational effects of dark matter using tools like the Hubble Space Telescope and the Chandra X-ray Observatory. What they found was eerie, giant halos of unseen mass surrounding galaxies, web-like structures stretching across space, forming a kind of cosmic skeleton that ordinary matter simply clings to. Roughly 85% of all matter in the universe is believed to be dark matter. That means everything we've ever touched, everything we've ever built or studied, from planets and moons to dust particles floating in sunlight, makes up less than 15% of what's really out there. And the part that remains, we have no idea what it is. Some believe it's made of exotic particles, WIMPs, axions, or sterile neutrinos, particles that don't behave like anything in the standard model of physics. Others wonder if it's not particles at all, but something even stranger. Maybe gravity behaves differently at cosmic scales. Maybe we're looking for something that doesn't exist, when the problem lies in our assumptions. That's the uncomfortable part, because if dark matter exists, we must explain what it's made of. But if it doesn't exist, if it's just a placeholder for our ignorance, then everything we know about gravity, physics, and space could be wrong. And this isn't a fringe idea. Some physicists have proposed alternative theories, like MOD, modified Newtonian dynamics, which suggests that gravity itself might behave differently in extremely weak fields. Others suggest space could be curved or twisted in ways we don't yet understand, subtly enough to escape detection, but dramatically enough to warp the motion of stars across galaxies. These are not easy ideas to accept. It's easier to believe there's a mysterious, invisible substance hiding in plain sight than to consider that the very rules we've used to describe the universe might be flawed. But NASA's models rely on dark matter being real. Without it, the elegant structure of cosmic simulations falls apart. And there's more. If dark matter is real, it might be everywhere, even here. It might be passing through your body as you read this. Billions of dark matter particles could be flowing through the Earth every second, undetected. Entire planets might drift through thick clouds of it without ever knowing. There are experiments on Earth trying to catch it, deep underground detectors shielded from radiation, in cryogenic labs hoping to spot the faintest bump of a particle against ordinary atoms. But so far, nothing, not a single confirmed detection. It's like chasing a shadow that doesn't cast one, and yet we can't ignore it. Galaxies rotate too fast. Gravitational lensing bends light in ways that demand extra mass. Colliding galaxy clusters like the Bullet Cluster show clear evidence that something massive passed through the chaos, something that didn't interact with normal matter at all. Still, the deeper implication lingers. If most of the universe is made of something we can't see, can't touch, and don't understand, then maybe space isn't just empty. Maybe it's layered, structured, filled with hidden forces and silent scaffolding that shape everything. And if dark matter is just one piece of the puzzle, what else are we missing? What if our understanding of empty space is as flawed as ancient maps that left entire continents blank? What if the void is not a void at all, but a canvas painted with forces and forms beyond anything we've imagined? These aren't just scientific questions, they're philosophical ones. They challenge what it means to know, to observe, to believe. And speaking of belief, there's a region of space far out and largely unexplained where belief meets silence, a place where satellites vanish, data glitches, and navigation turns chaotic. It's been called the Bermuda Triangle of space. The Bermuda Triangle of space. There's a stretch of Earth's orbit that makes even seasoned NASA engineers uneasy. It doesn't look different from any other part of the sky, but when satellites pass through this invisible zone, strange things start to happen. Instruments flicker, data becomes corrupted, entire systems shut down for reasons that defy logic. This unsettling region is known as the South Atlantic Anomaly. It hovers just off the coast of Brazil, over a wide swath of the South Atlantic Ocean, and it's often been called the Bermuda Triangle of space. Not because of sea stories or vanishing ships, but because of how unpredictable it makes our most advanced machines behave. NASA knows this zone well. Every time the International Space Station passes over it, astronauts are instructed to power down sensitive electronics. Hubble, too, shuts its eyes when crossing this patch of sky. It isn't superstition, it's protocol, because something is wrong there, and no one fully understands what. At the heart of the anomaly is Earth's magnetic field, our planet's invisible shield against solar radiation and cosmic particles. It protects us from the solar wind, deflecting high-energy particles and preventing them from frying electronics or harming life. But over this particular region, the field weakens, not by a little, but by a lot. Earth's magnetic field isn't perfectly centered. Its core is restless, liquid metal swirling in complex patterns, and that motion shifts the field. In the South Atlantic anomaly, it thins out like a frayed net. This allows radiation from the Van Allen belts, two zones of high-energy particles trapped by Earth's magnetism, to dip unusually low. And when they do, satellites get bathed in a storm of radiation they weren't designed to handle. Electrons pierce sensitive detectors, sensors glitch, memory chips flip bits. It's called a single event upset, and it can cause anything from a small error in a photo to a complete loss of a spacecraft's orientation. Some satellites have even been permanently damaged after lingering too long in this invisible hazard. But the anomaly is not a fixed scar, it's alive. It shifts over time, drifting slowly westward as Earth's magnetic field continues its restless churn. Some scientists believe it's a symptom of a much bigger process, something that might hint at an upcoming magnetic pole reversal. Because here's the thing, Earth's poles flip. Not suddenly, but over thousands of years, the north becomes south, and south becomes north. And when that process begins, the magnetic field grows weaker and more chaotic, exactly what we're seeing with the anomaly. If we really are entering a reversal phase, then the South Atlantic anomaly might just be the first crack in the armor. There's a deeper question that follows, one that NASA doesn't have an answer for. Could this weakening field affect more than just electronics? Could living things exposed to increased radiation begin to show changes over time? Could the anomaly in its subtle distortion of Earth's shield influence life in ways we haven't begun to measure? Some researchers have noted that certain low orbiting satellites experience temporary blindness or orientation loss while passing through the anomaly, especially when exposed to solar storms. It's almost as if something invisible is clawing at them, disrupting their balance, reaching through the electromagnetic veil. And while the data is technical, the feeling it leaves behind isn't. It's unease. Because we like to believe space is out there, far away, removed from our daily lives. But the anomaly proves that space, in all its chaos and radiation and unpredictability, brushes right up against us. It dips low, reaching toward the planet like a cosmic hand, reminding us how fragile our technology truly is. It's not the kind of thing that gets headline coverage. It doesn't make the evening news. But every satellite operator knows its name. Every astronaut is briefed on its effects. Every NASA mission is designed with it in mind. It's a patch of sky you don't want to linger in, not because of monsters or myths, but because it's real. A scientifically measured zone where the rules warp, where silence isn't peaceful, it's dangerous. And even now, as you drift through this story with me, dozens of spacecraft are orbiting quietly above us. Some of them are in the anomaly's reach right now, their instruments flickering, their data feeds humming with static, and no one knows why it's happening, only that it does. It's enough to make you wonder what else might be touching Earth from above. Because as strange as the anomaly is, it's not the only mystery just beyond our atmosphere. Somewhere out there, farther still, is a signal that returned. One NASA never expected to hear again. A radio burst from deep space that once came and went, and then years later came back again. The radio signal that returned. While satellites scrambled and flickered in the grasp of the South Atlantic anomaly, NASA's deep space antennas turned their attention to something even more mysterious. A signal, not a random blip, not static, but a message like pattern pulsing from far beyond our solar system. At first, it was easy to dismiss. Space is noisy. Radio telescopes pick up all kinds of electromagnetic chatter, from quasars, pulsars, even leaking microwave ovens on Earth. But this one was different. It was steady, regular, and it seemed to be coming from deep space, not from anything local. The signal was first detected in a narrow radio frequency band that is often used by researchers in the search for extraterrestrial intelligence, the so-called water hole between 1420 and 1666 megahertz. It's a quiet zone, astronomically speaking. Not many natural phenomena emit strongly there, which is why, when something does, it gets noticed. This signal wasn't just a spike or a burst, it pulsed with precision. It repeated in perfect intervals like a ticking clock, not random at all, structured. That was the part that made scientists shift in their chairs. Observatories around the world tried to tune in. The signal would fade, then return. It was transient, as if it didn't want to be found, or as if it was moving. Sometimes it would vanish entirely for hours or days, but when it returned, it was always the same frequency, the same pulse, like it was waiting. NASA wasn't the only one paying attention. The SETI Institute, using its powerful Allen telescope array, began to track it. Their analysts noted that the intervals between the pulses were exact, down to fractions of a second. That kind of precision isn't common in nature. Pulsars, for example, can pulse rhythmically, but they tend to wobble over time. This one didn't. It was unnervingly perfect. And then it stopped. Just like that, no gradual fade, no weakening signal. It simply went silent, as if something on the other end had turned it off. For days, then weeks, the team kept listening. No response, until something else happened, something subtle but chilling. A new signal appeared, different frequency, different pulse, but the same location, and this time the pattern seemed reactive. Instead of a simple rhythm, the new signal responded with variations that mirrored some of the data that had been beamed out toward it in earlier attempts at contact, as if it had listened, and now it was answering. Some scientists suggested caution. It could be a coincidence, an echo of some natural, unknown phenomenon. Others weren't so sure. The frequency was too precise, too calculated. It was as if something had heard us and then replied just once to let us know it did. There was no language, no clear message, just a pattern, and then silence again. That silence stretched on for months. Even now, the data from that event lives in encrypted archives, shared among radio astronomers and researchers under strict confidentiality. Public statements mention anomalous bursts and non repeating transient events, but off the record, there are murmurs of something more, of a signal that acted more like a conversation than a cosmic accident. No one has confirmed what it was, and no one has heard from it since. What's perhaps most disturbing is that the original signal came from a region of space we thought was empty, not a galaxy, not a star system, just dark interstellar space. Which means whatever sent it either isn't from where we expect life to be, or it isn't traveling in the way we think life would. The question left behind wasn't just who sent it, but why did they stop? Was it a mistake? A misfire of something not meant for us? Or was it intentional silence? As if after being seen, they withdrew, because maybe we're not meant to reply, and maybe, just maybe, the signal that came back wasn't meant as an invitation. As scientists try to interpret what little data they have, theories swirl. Could it have been an interstellar probe, a silent observer relaying what it heard before slipping away? Or was it something else entirely, a warning? What's unsettling isn't just the signal itself, it's what followed. The pattern repeated, the response, the silence. And just like that, something changed in the way NASA listens to space. Now every new signal is measured not just for its strength or frequency, but for its intent. Because after that brief, eerie whisper from the dark, we realized we're not just listening anymore, we're being listened to. The Bota's Void. After that strange moment when a signal seemed to reply to Earth and then abruptly fell silent, astronomers began to wonder if we were looking in the wrong places. Or perhaps if something out there was carefully choosing where not to be found. And then came the Bota's Void. It's one of the most unsettling features in the known universe, not because of what's inside it, but because of what isn't. This vast, empty region lies in the direction of the Bota's constellation. When first discovered, it looked like a mistake, a glitch in the survey, a patch of night sky that appeared to be missing everything. But the data held up. Again and again, telescopes scanned the area, and again they found nothing. The Bota's void spans about 330 million light years across. That's more than 3 times the size of the entire Milky Way galaxy. In cosmic terms, it's like looking into a massive pitch black bubble that stretches farther than we can truly comprehend. A hole in the sky where galaxies should be but aren't. And this wasn't just a case of empty space between galaxies. The universe has plenty of that. This void was different. It was almost entirely devoid of matter. It contains far fewer galaxies than astronomers expected, over 10,000 times fewer than the average region of similar size. The more they studied it, the stranger it got. Galaxies are usually scattered across the cosmos like grains of sand, clumped here, stretched there, forming webs and clusters and tendrils. But the Boetes void doesn't follow that pattern. It breaks it. It sits like an island of nothingness in an otherwise populated sea. And no one fully knows why. Some theorize it's just a natural fluctuation, a rare but possible gap in the cosmic web where matter didn't clump together after the Big Bang. Others aren't so sure, because the shape of the void is strangely spherical. That symmetry has puzzled scientists. In nature, large scale structures rarely form such tidy boundaries without a cause. Something shaped it. Some researchers have even wondered, in whispers and mostly outside of peer reviewed papers, if the void might be artificial. Not in the sense of being built like a structure, but cleared. One eerie idea is that something, some force, natural or not, swept through this region of space, displacing or destroying anything in its path. Galaxies, stars, dust, gone. Of course, that's speculation. There's no evidence that anything was removed or erased. And yet, the emptiness is so profound, it invites questions no one can quite answer. What makes the Boyd's void even more haunting is how silent it is. In other areas of deep space, even where galaxies are sparse, there are faint radio emissions, gravitational lensing, or stray light from ancient stars. But the Boyd's void gives off almost nothing. It's not just visually empty, it's energetically cold, quiet, still. Some have described it as a cosmic scar left behind by something ancient and powerful. Others think it could be a hint of new physics, a place where the rules of gravity or expansion might have behaved differently. Perhaps even a bubble from another universe pressing into ours, creating a pocket where matter never took hold. And then there are those who think the Buoy's void is more like a message, not sent intentionally, but left behind as a consequence of something else, like a footprint, a place in the cosmos that says something happened here, but no one knows what. We've mapped galaxies farther away than the void. We've photographed the afterglow of the Big Bang itself, and yet this massive hollow remains unexplained, a cosmic silence that stares back at us. It doesn't flicker, it doesn't hum, it doesn't move, it just is. And that's perhaps what unsettles astronomers most, because in a universe full of motion, birth, collision, and decay, a place that big and that still shouldn't exist. It's like finding an abandoned cathedral in the middle of a living city, untouched, dark, and massive, as if everything that was once inside it had quietly vanished. Some wonder if the Buwat's void is a glimpse of our universe's future, a preview of what's to come when expansion stretches all galaxies beyond each other's reach until everything goes quiet. Others still ask whether something is hiding inside it, shielded from view, concealed not by camouflage but by absence. And so scientists keep watching. They turn their most powerful instruments toward that empty shell in the sky, not expecting answers, but hoping for movement, for sound, for something. But the void gives nothing. It waits. The Martian magnetic pulse. Just beyond the edge of the Boot's void, our gaze turns back inward to a planet far closer to home, yet still full of secrets. Mars. It's dry, silent, and rust colored. a world frozen in time. At least, that's how we used to think of it. A dead rock, cold, empty, and predictable. But then came insight. In 2018, NASA's InSight lander touched down on the surface of Mars with a specific purpose: to listen, not just for meteor impacts or surface tremors, but for the planet's internal heartbeat. Its sensors were some of the most sensitive ever sent into space, designed to detect vibrations beneath the surface, tiny tremors called Marsquakes, and any fluctuations in the planet's magnetic field. And that's when something strange happened. Around midnight, during multiple nights on Mars, InSight picked up odd magnetic pulses. They weren't loud, they weren't violent, but they were precise, sharp, unexplained bursts of magnetism, spikes that appeared out of nowhere, always at the same time, midnight, local Martian time, and vanished just as quickly. At first, scientists wondered if it might be a glitch, some interference, but the instruments held steady. The signal was real. What's strange is that Mars isn't supposed to have a strong magnetic field at all. Billions of years ago, it did, similar to Earth's, but that field collapsed, likely due to the cooling of its core. Today, only remnants remain, scattered across patches of ancient crust. It's one reason Mars has no protection from solar radiation. Its skies are open, its surface exposed, and yet these pulses suggested something under the surface was still active, still alive, in a way we didn't expect. The magnetic spikes were small but powerful enough to surprise the team. They didn't fit any known pattern of atmospheric behavior. They weren't tied to solar winds or radiation storms. And they didn't sync with the planet's crustal features in any clear way. Something was making them, something inside. Researchers tried to model the signals. Maybe leftover pockets of magnetized rock were heating and cooling in a strange rhythm. Maybe pressure changes beneath the crust were flexing materials in a way that released these pulses. But nothing quite matched. Even more curious, the magnetic field around InSight's landing site, Elysium Planitia, was found to be 10 times stronger than expected. 10 times. And this wasn't just a single spike or reading. This was the entire region humming with more magnetic energy than models had predicted. Was this ancient magnetism left over from Mars's past? Or could it be something happening now, something beneath the surface, hidden from view? InSight also detected Marsquakes, some shallow, some deep, many without a known source, and in some cases, magnetic pulses followed these quakes or came before them, but not always. There was no consistent cause and effect, just strange activity, as if Mars had moments of waking, only to drift back into silence. These midnight pulses became one of the most puzzling aspects of InSight's mission. They didn't happen every night, but when they did, they were eerily timed, like a clock ticking inside the planet. And it wasn't just the magnetometer that noticed strange things. Seismic sensors picked up tremors that didn't resemble quakes caused by fault lines. Some seemed to echo upward, as if something had shifted deep below, and the energy had rippled to the surface from inside out. These weren't aftershocks, they were something else. Could Mars have a partially molten core? Could underground reservoirs of material still be moving, shifting, flexing in ways we can't yet visualize? The more data came in, the more it challenged the picture of Mars as a geologically dead world. And then came the idea that maybe, just maybe, the magnetic signals weren't geological at all. What if they were electrical? In theory, if subsurface materials like briny water or metallic minerals were moving, they could generate magnetic fields, especially if those movements were rhythmic like tidal flows. But tidal flows require a pull, a force. Mars has no large moon. Its rotation is slow, and its atmosphere is too thin for regular pressure cycles, strong enough to explain the pulses. So, where's the pull coming from? Some have wondered if deep underground, Mars might still have pockets of conductive material, perhaps even water, pressurized and shifting in ways that create short, sharp bursts of magnetism. Others go further. They ask whether these signals are the result of past interactions or something still ongoing, maybe an echo of ancient processes, or the stirrings of a world that's not quite as asleep as we thought. Whatever the cause, the midnight pulses remain, not constant, but persistent enough to suggest they aren't random. They seem to follow rules, just not any rules we fully understand. And as Insight listened through countless Martian nights, it became clear that even in the quiet, cold dark, Mars still whispers, and sometimes it hums. Unexplained gamma ray bursts. If Mars whispers in the dark, then some parts of the universe scream, not with sound, but with energy, because every so often, somewhere far beyond our galaxy, the sky flashes, not with light we can see, but with something much more intense: gamma rays. They arrive suddenly, without warning, without a pattern, and for just a few seconds, they outshine entire galaxies. NASA first noticed them by accident. Back in the Cold War era, American satellites were designed to monitor Earth for secret nuclear tests. These satellites picked up bursts of gamma radiation, but they weren't coming from Earth. They weren't coming from the moon. They were coming from deep space. The signals were short, sometimes just a fraction of a second, other times a few minutes, but the power behind them was staggering. Gamma rays are the most energetic form of light in the universe. A single burst can carry more energy than our sun will produce over its entire 10 billion year lifetime. That's not poetic exaggeration, that's a scientific estimate. But these bursts didn't behave like ordinary cosmic events. They weren't like supernovas, which fade slowly. They weren't like quasars, which glow for millions of years. Gamma ray bursts flicker once and vanish. For decades, astronomers struggled to pinpoint where they came from. Their energy was so high and their duration so short that traditional telescopes often missed them entirely. It was like trying to take a photograph of lightning with a camera that blinks once every few minutes. Eventually, NASA launched satellites designed to spot them, like the Swift Observatory. These machines could catch the bursts as they happened, pivot quickly, and alert ground-based telescopes to look at the spot in the sky where the flash occurred. But what scientists saw only deepened the mystery. Most gamma ray bursts came from galaxies billions of light years away, which meant the explosion we were seeing now actually happened billions of years ago, long before our sun formed, long before Earth existed. Some bursts lasted under 2 seconds, others stretched up to a few minutes. The short bursts were especially confusing, too quick for massive star collapses, too powerful for any known object to explain. The leading theories? Some involve neutron stars colliding, tiny ultra-dense cores of dead stars smashing into each other at nearly the speed of light. When they crash, they ripple the fabric of space and emit an intense, focused beam of gamma radiation. Others suggest these bursts come from hypernova, an incredibly rare type of stellar collapse, even more powerful than a supernova. In these events, the core of a star collapses so violently it punches through the outer layers, sending jets of gamma rays hurtling into the void. But even these explanations don't cover all the data. Some gamma ray bursts show characteristics that don't fit either category. They appear from empty regions of space where no galaxy is visible, or they produce afterglows that behave differently, fading slower or changing color in ways no one predicted. And then there's the shape of the bursts. Many are beamed like spotlights, which means we only see them if Earth happens to be in the path of that narrow jet. That's a disturbing thought, because for every gamma ray burst we detect, there could be hundreds more happening that we'll never know about, simply because the beam isn't pointed at us. Now imagine one of those jets aimed directly at Earth. It would slice through our atmosphere like a blade, strip away the ozone, irradiate the surface, the sky would glow purple, the air would change, and biological life as we know it could be altered forever. Thankfully, no such burst has occurred nearby in recorded history. But the universe is old, and it doesn't warn us. Some researchers suspect a gamma ray burst may have caused a mass extinction event on Earth hundreds of millions of years ago. The fossil record shows a sudden collapse in biodiversity. Plants, marine life, and atmospheric chemistry all shifting abruptly, and there's no crater, no asteroid, just silence. Even more haunting are the orphan afterglows. These are light signals that resemble the fading glow of a gamma ray burst, but without the initial flash. Some believe they're the side effect of bursts that happen just off axis, ones we didn't catch directly, but whose lingering energy eventually drifted into our field of view. Echoes from a cosmic explosion we never saw coming. NASA continues to monitor the skies. Its satellites wait silently, sensors tuned to the highest frequencies of light. When a gamma ray burst hits, it sends out alerts, warnings that something powerful, ancient, and unpredictable has just torn through the cosmos. And while we still don't fully understand them, one thing is certain: there are parts of the universe where energy moves like a tidal wave. Sudden, relentless, and deeply, deeply mysterious. The dark flow problem. As if gamma rays weren't strange enough, there's something else out there, something much slower, but just as unsettling. It's called the dark flow, a quiet motion that shouldn't exist. Imagine you're floating in a cosmic river. Galaxies are drifting along with you, pulled gently by gravity, swirling with the expansion of the universe. Everything should be random, chaotic, a dance of billions of stars moving outward in all directions after the Big Bang. But then, something strange happens. Some galaxies aren't just drifting outward, they're heading in the same direction, together, in a line, as if something massive, far outside our known universe, is tugging on them, not just a few, but hundreds of galaxy clusters, each containing thousands of galaxies, all moving in the same direction, like leaves caught in a hidden current. NASA first noticed this motion using data from the Wilkinson Microwave Anisotropy Probe, or WMAP for short. This satellite wasn't even looking for movement, it was scanning the afterglow of the Big Bang, the faint background radiation that blankets the universe. But as scientists dug into the data, they saw an odd pattern. Some galaxy clusters were shifting in the same exact direction, at similar speeds, faster than they should be, and they weren't slowing down. What made it truly baffling was that this movement wasn't toward anything we could see, no nearby supercluster, no known gravitational source. They were flowing toward something beyond the edges of our observable universe, something we can't detect, but that seems to have mass, a lot of mass. This synchronized drift became known as dark flow. The word dark doesn't mean it's black or invisible in the traditional sense. It means we don't know what's behind it. We can't see the source. We don't know what's doing the pulling or why. And that's what makes it so deeply uncomfortable, because our understanding of gravity, motion, and space assumes that what we see is what there is. If galaxies are moving in unison, they should be responding to a known gravitational field. But here, they're responding to something outside our cosmic horizon, something that's never interacted with us directly, yet exerts an influence over enormous distances. The speeds involved are staggering. Some of these clusters are moving at over 2 million miles per hour, all in a direction near the constellation Centaurus. And they aren't being pushed outward by the universe's expansion. They're being dragged sideways relative to everything else. It's as if some hidden object, maybe beyond the edge of space we can see, is pulling with invisible fingers, a great gravitational hand yanking entire swaths of the cosmos in its direction. Some scientists have proposed radical explanations. One idea is that there might be another universe next to ours, a region of spacetime so massive and dense that its gravity leaks into our own universe and tugs on matter from across the border. If that's true, it would mean our universe isn't alone. It's part of a multiverse, and we're feeling the gravitational pull of a neighbor. Another theory suggests massive structures left over from before the Big Bang, buried in cosmic inflation, could still exert influence from the unobservable past. Ancient wrinkles in the very fabric of space, imprinted before time as we know it even began. And yet others propose it's simply an illusion, that we're misinterpreting the data, or that something closer, something unknown, is skewing our view. But after years of new observations from Planck and other missions, the signal hasn't disappeared. What's most unsettling is how little we can do with this information. The observable universe is a kind of cosmic bubble. We can only see as far as light has traveled since the Big Bang, roughly 46 billion light years in every direction. Anything beyond that is invisible. Not because it's hidden, but because its light hasn't had time to reach us. But dark flow seems to point beyond that horizon. It hints at a deeper structure to the universe, one we're barely beginning to sense, like hearing the echo of a drum from behind a closed wall. We can't see what made the sound, but we feel the tremor. It makes you wonder what else might be lurking beyond the edges of our vision. Not everything in space is violent or bright or loud. Some mysteries, like dark flow, move in silence. They don't announce themselves with explosions or gamma rays. They just pull softly, steadily, and wait for us to notice. The lake on Titan that shouldn't exist. And then there's Titan, Saturn's largest moon. From a distance, it looks like a hazy orange orb wrapped in thick clouds. But beneath that blurry atmosphere lies one of the most mysterious places in our solar system, a world that's both eerily familiar and completely alien. Unlike most moons, Titan has weather, real weather, clouds, rain, rivers, even lakes. But there's one key difference. It's not water that flows there. It's methane. Liquid methane falls from Titan's sky like rain. It carves riverbeds, it pools in valleys, it even forms seas and lakes so vast they shimmer like mirrors when the light hits just right. The Cassini spacecraft, sent by NASA to orbit Saturn, gave us our first real look at this strange world, and what it found defied expectations. As Cassini flew over Titan's North Pole, it sent back radar scans of one particularly large lake. It was nicknamed Magic Island for reasons that became clear soon after. This lake wasn't like the others. Most methane lakes had rough, wave-like textures, indicating wind or surface movement. But this one, it was completely smooth, smoother than glass, reflecting radar signals like a perfect mirror. At first, scientists thought it might just be a frozen surface. After all, Titan's surface is unimaginably cold, around minus 290 degrees Fahrenheit. But Cassini's instruments detected something strange. The lake wasn't frozen, it was liquid, and even more surprising, it was warm. Not warm like Earth's summer lakes, but warmer than it should have been, given the icy conditions all around it. Warmer than the surrounding terrain. It was as if something underneath was heating it gently from below. A slow, steady warmth keeping the methane in liquid form while everything else should be solid. And that raised unsettling questions. What's warming the lake? Some scientists proposed geological activity. Maybe Titan has a subsurface layer, an ocean of slushy ammonia and water, and heat from the moon's core is rising through cracks. This could allow pockets of methane to remain liquid at higher than expected temperatures. But there's a problem with that theory. Titan shouldn't have that much internal heat. It's too small, too far from the sun. It doesn't have enough radioactive decay in its core to sustain that level of thermal energy, at least not according to current models. So, what's causing it? Other researchers wondered if the lake's unusual properties were due to its composition. Maybe it had dissolved gases or exotic materials that changed how it absorbed heat. But again, none of those explanations fully account for the smoothness, reflectivity, and unexpected temperature profile all at once. Even more curious, the lake changed over time. Cassini's scans showed that the surface became less reflective during later passes. Some features appeared, then vanished. It was almost like the lake was breathing, as if it had tides or something moving within it. Features that couldn't be explained by wind or weather alone. Some scientists suggested cryovolcanism, the idea that cold moons can erupt icy slurries instead of molten lava. Titan might have methane volcanoes deep beneath the surface, releasing warm liquid that occasionally bubbles up. If that's the case, it could explain the lake's warmth, but again, no such volcano has been directly seen. Others began to ask if something else entirely was going on. Because the lake didn't behave like any natural body they'd studied. It was too flat, too stable, too warm. It had no wind driven waves, no visible inlets or outlets. It simply existed, as if placed there, waiting. And Titan, with its thick orange atmosphere, keeps most of its secrets well hidden. You can't see through the haze with regular cameras. You need radar, infrared, careful measurements. Which means that for every strange lake we've found, there may be dozens more just beyond reach. The smoothness of the lake also created speculation in less conventional circles. Could it be a frozen remnant of something artificial? A collapsed dome? A reflective structure covered in liquid hydrocarbons? There's no evidence for this, but the lack of a good explanation leaves the door cracked open. Because science doesn't fear mystery, it follows it. And Titan, more than almost any other moon, continues to offer puzzles with no easy answers. The lake that shouldn't exist still lingers in the data, marked in Cassini's logs. Quiet, still, warm, silent, and whatever keeps it that way remains unknown. The Whispering Nebula. In the black silence of deep space, we don't expect to hear anything at all. There's no air out there to carry sound, no breeze to rustle, no waves to crash. Space, by definition, is silent, but sometimes that silence isn't as empty as we thought. NASA's deep space instruments, especially spectrometers and radio telescopes, are designed to listen in ways our ears never could. They translate invisible waves into data, into sound, into something we can interpret. They listen to the hum of planets, the pulse of stars, the distant churn of galaxies. And somewhere in those translations, a pattern began to emerge, a whisper. It started faint. In the data collected from certain nebula, massive clouds of gas and dust floating light years across, researchers began detecting vibrations. Not in sound, exactly, but in energy, spectral signatures. And when these signals were converted into audio frequencies, something eerie happened. They didn't sound like static or white noise or the expected hum of particles. They sounded familiar. Long, slow pulses, rising and falling, with the odd dip or tremble that resembled breath, or pitch, or tone. Not language, no, but something close to a human voice, something between a sigh and a chant, a soft, distant note that seemed to echo even though space has no walls to bounce off of. Scientists, naturally, were skeptical. Audio processing can sometimes produce illusions, pareidolia of sound, where the brain makes meaning where there is none, like hearing voices in wind or music in machinery. But this wasn't just one instance. It wasn't just one nebula. Multiple nebulas, scattered across different parts of the galaxy, were registering these faint, tone like signals, and not just from one type. Star forming regions like the Eagle Nebula, supernova remnants like the Crab Nebula, even dark, cold clouds where no stars yet burned. The whispers came in different forms. Some resembled slow modulations, almost like a breath being drawn. Others had rhythmic pulses, slow at first, then accelerating. A few even displayed harmonics, layered frequencies that behaved like musical chords. NASA doesn't claim their voices. They've been very clear about that. But the resemblance is hard to ignore, not just because of how they sound, but because of where they're found. Because many of these whispering nebula sit in places where something dramatic is happening: a star being born, a star dying, a region of space where energy collapses, reforms, explodes, and rebuilds. It's in these transition points, these cosmic thresholds, that the whispers seem to gather. One explanation is that we're simply hearing the byproduct of extreme forces: high energy radiation colliding with magnetic fields, charged particles spiraling in complex patterns. These could produce frequencies in the radio or X ray range that, once converted, resemble tones, but that still doesn't explain the pattern, the harmony. The fact that in some cases the tones seem to shift in response to solar activity, almost as if reacting, or the fact that when layered together, recordings from different nebula seem to align, like instruments in an orchestra that have never met, yet somehow play in tune. There are stranger theories too. Some researchers wonder if the whispers are echoes, ancient signals bouncing through interstellar space, distorted by time and gravity. Others suggest they're relics of stellar memory, imprints left by supernovae as they unravel, like scars in the fabric of space itself. And a very few, ask if it's something more, if intelligence on some scale might be shaping the frequencies, not with intention, maybe, not with meaning we'd understand, but as a byproduct of some cosmic thought, a drift of consciousness embedded in matter, or simply the sound of the universe processing itself. After all, we don't know what intelligence would look like on a cosmic scale. We assume it must speak. But what if it resonates instead? The whispers aren't heard through ears. They're seen in data. They appear in the spectrograms like fingerprints, faint, ghostly trails that fade as quickly as they're captured. They don't repeat like coded messages. They don't carry information in any traditional sense, but they linger, and if you slow them down, stretch the frequencies, they sound hauntingly close to something human, like a voice at the edge of sleep, fading, returning, then gone. Astronomers continue to monitor these nebulae. The data is still coming in, still whispering, still undecoded. And somewhere in the dark, those clouds of dust and gas drift onward, not silent as we once believed, but humming softly with the music of something ancient, and possibly listening back. The red light behind the moon. Just when it seems space couldn't grow any stranger, something appears in the most familiar place of all: the moon, our constant companion in the sky, quiet, steady, always showing the same face to Earth. For all its stillness, the moon holds mysteries too, some long studied, others still unfolding. And one night something appeared where it shouldn't have. It was during a total lunar eclipse, one of those rare moments when the Earth moves perfectly between the moon and the sun. The moon falls into Earth's shadow, and instead of disappearing into darkness, it usually glows a soft red. This is because sunlight passes through Earth's atmosphere, bending and scattering until only the reddish wavelengths make it around the curve of our planet and reach the moon's surface. That part is well understood. It's why people sometimes call it a blood moon. But during one such eclipse, astronomers watching through powerful telescopes noticed something that didn't fit. As the moon passed into total shadow, when it should have been bathed in only that usual rusty red, a second red glow appeared. Only this one wasn't on the moon's surface. It hovered just beyond the moon's dark edge, a red shimmer, faint but visible, sitting behind the part of the moon that faces away from Earth. For a moment, it looked as if something was glowing behind the moon itself, casting a halo from the far side, a side hidden from direct view. It didn't behave like a lens flare or a camera glitch. Multiple observers in different places saw it. The glow was consistent across instruments, and it lingered, not flashing, not fading immediately, but glowing steadily for the duration of the eclipse's peak. Naturally, attempts were made to explain it. Some thought it might be scattered light from the sun, bending in strange ways around Earth's atmosphere, but the angles didn't line up. Others suggested reflections from satellite panels or orbital debris, yet those move fast, flickering or blinking, not hovering in a fixed position for several minutes. What made it stranger was the color. It wasn't a pale red like a sunrise, it was deep, almost crimson, more saturated than anything expected from atmospheric refraction. Not bright enough to light up the moon's surface, but enough to be seen as a separate source, a glow, not a reflection. The moon doesn't have an atmosphere, it can't reflect light from behind, and its far side, often misnamed the dark side, isn't actually dark at all. It gets sunlight like the near side does. But during a full eclipse, it's fully in shadow, meaning nothing from Earth should be lighting it from behind. So, where was the glow coming from? One theory suggested it could be a plasma event. Occasionally, space is filled with charged particles, especially near the Earth Moon system, where solar winds interact with magnetic fields. These particles can cause brief silent auroras, not on the moon, which lacks a magnetic field, but in the space nearby. Maybe some burst of ionized gas lit up unexpectedly, but that still didn't explain the shape. It wasn't scattered or random. It hugged the outline of the moon's far side, almost like a rim light. The effect looked artificial, clean, and for a few moments it gave the illusion of something enormous, backlighting the moon as if a giant red beacon were rising silently behind it. There were no known satellites in the right position, no solar flares strong enough to cause that level of atmospheric disturbance, no spacecraft launches, no reported anomalies from NASA or international agencies. Just a quiet glow, captured in photos, witnessed through lenses, and then gone. After the eclipse ended, the moon returned to normal, no lingering heat, no trace, and in the silence that followed, astronomers were left with data, some spectral readings, a few puzzled notes, and hours of video showing the impossible. It didn't return during later eclipses, not quite the same way. Some observers have reported flickers of color, odd shadows, even fast-moving objects during similar events, but nothing as vivid or stationary as the red light behind the moon. To this day, the incident remains open. Some call it a freak event, a trick of scattered particles. Others think it was something else entirely, a reminder that even the most familiar objects in our sky can still surprise us. And perhaps not everything that moves in the darkness is meant to be explained. What NASA doesn't say. For all the incredible things NASA has shown the world, the glowing images of distant galaxies, the rovers crawling across Martian soil, the towering rockets slicing through Earth's atmosphere, there's just as much, if not more, that we haven't seen. Not everything gets shared. Not every discovery makes it to a press release or public archive. NASA is, after all, a government agency. It works alongside the Department of Defense. It runs missions in coordination with national security interests. And sometimes those interests mean silence. There are records, thousands of them, filed quietly in corners of government databases. Some are labeled partially released. Others are blacked out, entire pages redacted. And some don't appear at all, known only because someone once referenced them and then moved on. Take the 1973 Apollo 17 report. Buried in a pile of post-mission analyses, there's a strange entry, a page labeled Lunar Anomalies, Visual Reports. Most of the page is visible, notes about terrain, light reflection, lens flare. But then a line appears, hand marked, unexplained motion above horizon, recorded 38 point, that's it. No explanation, no follow up. And when the footage from that timestamp is reviewed, there's a sudden cut, a brief pause in transmission, nothing else. Then there's the STS-48 mission, a routine space shuttle flight in 1991. Officially, it was just a standard Earth observation run, but footage from the shuttle's external cameras showed something odd. A bright object moving at high speed, then changing direction mid-flight, not falling, not drifting, turning. NASA explained it as ice particles reacting to engine bursts. But multiple physicists, including some within the agency, raised doubts. The object accelerated, something ice simply doesn't do on its own. Years later, requests for internal memos about the event returned only redacted pages and vague summaries. In 2004, a NASA researcher working on deep space anomaly analysis submitted a proposal to study non-standard electromagnetic disturbances detected beyond the heliopause, the region past the edge of our solar system. The disturbances didn't match known solar radiation patterns. They pulsed in sequences. The proposal was denied, but the research logs it was based on, those are now missing from the archive entirely. Why? Another mystery circles the 1998 NEAT mission, Near Earth Asteroid Tracking. In one run, the system logged a fast-moving object that approached Earth from a highly unusual angle, almost perpendicular to our orbital plane. It didn't match asteroid movement. It didn't leave a debris trail. A few frames of the object exist, showing a long shape, reflective, possibly metallic, but the follow-up observations were lost. The original telescope logs were reportedly corrupted. That's the official word. Even the legendary Voyager missions, celebrated for their journeys into interstellar space, have small shadows in their wake. In 2013, after Voyager 1 crossed into interstellar space, it picked up a low, constant hum, not cosmic background radiation, something more tonal. When NASA released the data, they published a cleaned-up graph. But the raw recordings, the unfiltered frequency traces, have never been published in full. Some frequencies reportedly were removed. The reason given? Signal noise. But some former employees have said the frequencies formed regular intervals, patterns, the kind not usually produced by random energy. Across decades, these little gaps pile up. Sometimes it's a missing video frame. Sometimes it's a line of telemetry data that just stops. Sometimes it's a quiet cancellation of a research initiative that seemed too strange, too open-ended. And then there's the classified side of NASA, the part almost no one talks about. Because while most of NASA is public and civilian, parts of its infrastructure are leased to military research. Satellites launched on shared rockets, observations cross-referenced with defense intelligence, missions rerouted without public explanation. In the late 1990s, an internal audit revealed over 7,000 NASA files were tagged with restricted access for reasons unrelated to current scientific protocols. When reporters tried to request more details under the Freedom of Information Act, they were denied, citing national security. So the question becomes, what don't they want us to see? Not in a conspiratorial way, not aliens in hangars or secret civilizations on Mars, but in a deeper, more unsettling sense. Could it be that space has revealed something, a pattern, a force, a strange law of physics that we're simply not ready to process, or not equipped to act on? Is there something out there that makes us feel small in a different way, not just because the universe is vast, but because it might be more complex, more aware, or more connected than we imagine? The unanswered questions aren't always about what we've seen. Sometimes they're about what's been quietly filed away and never spoken of again. Maybe some things weren't meant to be found, but space gives them up anyway, not with announcements or bright arrows pointing the way, but with whispers, with shadows, with glitches in a data stream, or a silence that grows too perfect to ignore. Space, for all its grandeur, doesn't shout. It hums, it pulses, it hides things in plain sight. And sometimes it leaves things just barely visible, like the edge of something huge disappearing around a corner. We've spent our time tonight exploring the odd, the unexplained, the unsettling fragments that NASA's missions have uncovered, not always with clarity, not always with understanding, but always with awe. The glowing dunes, the cold spots, the spinning galaxies that twist against gravity's pull. None of them ask for attention. They're just there, waiting. And that's the strange part, isn't it? The universe doesn't seem in a hurry to explain itself. These mysteries drift in silence, indifferent to our curiosity. No labels, no guideposts, just the quiet suggestion that there's more, always more than we can reach. It's like walking into a vast library where most of the books are sealed shut. We press our ears against the covers, hoping to catch a single word from the stories inside. And every now and then, we do. A flash of noise, a strange pulse, a red light behind the moon, a signal that shouldn't exist. Maybe we were never meant to see all of it. Maybe the most extraordinary truths of the universe weren't meant for us, or at least not yet. But space doesn't always keep its secrets. Sometimes it lets one slip, like the scream-like sound picked up in deep space that still can't be explained, or the void so large it makes us question how galaxies even form, or the radio signal that echoed back just once in perfect rhythm before disappearing forever. These aren't just strange moments, they're quiet invitations, invitations to wonder, to question, to listen again, and maybe to dream of what else might be out there, just past the edge of everything we think we know. So, as you settle into rest, I'll leave you with a question that lingers like a soft trail of stardust. What do you think that unnamed red object is? You remember, the one seen drifting alone in the black, distant and silent, without a name or explanation. NASA recorded it, but never labeled it. Is it a rogue planet? A fragment of something larger? A probe from somewhere else? Or maybe it's none of those things. Maybe it's something we haven't even imagined yet. I'd love to hear your thoughts. If you're still with me and your eyes haven't drifted shut just yet, let me know in the comments. What was the moment that stayed with you the most tonight? Was it the dark flow pulling galaxies towards something unseen? Was it the magnetic pulse on Mars that always came at midnight? Or was it the lake on Titan, strangely warm and still? These aren't just stories, they're questions that haven't finished asking themselves. And if you enjoyed wandering through them with me, if these gentle mysteries helped quiet your thoughts, helped you fall just a little deeper into stillness, I hope you'll tap the like button or subscribe for more strange, soothing science. This little channel lives on curiosity and on people like you who find comfort in the unknown, who fall asleep not to answers, but to possibilities. And I think there's something beautiful in that. So now, wherever you are in the world, maybe you're lying in bed beneath a heavy blanket, or maybe you're watching a distant sunrise creep through the window, I hope you'll take one last deep breath. Let the tension go, let the wonder stay, because maybe, just maybe, we're not supposed to know everything. Maybe the mystery itself is the message, and maybe that's enough for tonight. Good night, fellow traveler. Sleep gently and dream of stars.